Night has settled over Earth. The rush of the day has faded. Streets grow quieter, cars fewer, windows dimming one by one as people drift towards sleep. A distant train sighs along its tracks. Somewhere, a dog barks once and then falls silent. Above it all, the sky stretches out wide, dark, and filled with steady points of starlight. High on hills and city rooftops, radio towers stand against that darkness. Tall metal frames, thin wires, red lights blinking in slow, patient rhythm. To the eye, they look silent and still. But from their antennas, something is always leaving. Radio waves. They slide into the night in thin streams and soft pulses. A song on a late station. A breaking news alert. A pilot's calm voice talking to a control tower. A phone call between two people sharing something they can't quite say out loud. All of it becomes tiny changes in electric and magnetic fields, lifted up and sent outward. Most of these waves fall back to Earth. They bounce off layers of the upper atmosphere, skim along mountain ranges and oceans, and slowly fade into a gentle hiss of static. But a small part escapes. Those signals rise through the thin top of the air and keep going, stepping quietly into space. If your eyes could see radio waves, you would see invisible shells growing around our world. Every second, new ripples expand from Earth at the speed of light. They pass drifting dust, small pieces of rock, and the dark paths of ancient comets. Each shell carries memories of voices and music, of fear and laughter and ordinary human days. From far above the solar system, with impossible vision, you would see a faint bubble wrapped around our planet. At its center, a tiny blue dot. Around it, layer after layer of radio light, like rings inside a tree. The oldest broadcasts lie farthest away. The newest cling close, still near the world that made them. If you are listening as you drift towards sleep, this is where you belong in that quiet glow. Your phone, your room, your small corner of the night are part of that web of signals. And if you'd like to keep traveling with these slow, starlit stories, you can subscribe and share where you are and what time it is. I read those little notes: New York at midnight, London before dawn, Karachi in the deep evening, like a second sky of human lights spread across the earth. That radio bubble has already stretched beyond Mars. It passes the cold stones of the asteroid belt, where silent fragments drift in long, lonely orbits. It brushes through the pale tails of comets swinging in toward the sun, those ancient travelers that have circled this star for longer than any human memory. Farther out, where sunlight grows thin and shadows deepen, the bubble reaches a distant giant, Jupiter. It hangs in the cold like a striped lantern. Wide bands of cloud wrap around its huge body in swirls of cream and rust. Storms bigger than Earth roll across its face and never truly rest. Lightning flashes deep inside, bright for a moment and then gone again. Around the planet, an invisible magnetic field stretches outward, trapping charged particles and shaping them into a faint, ghostly glow. That field sings in radio. Particles spiral along its invisible lines, turning and twisting as they go. To big radio dishes on Earth and antennas on passing spacecraft. Their motion becomes sound, hisses, crackles, and long, rising tones. In radio, Jupiter is loud. It never really stops talking. Around this giant world, many moons circle. Some are small and dark, scarred by ancient impacts. Some are bright and icy, shiny as crushed glass. One hides a deep ocean beneath a shell of frozen water. Another is restless and volcanic, throwing plumes of hot material into space. Each moon follows a careful path, held in place by Jupiter's heavy gravity. Now the bubble of Earth's radio light washes over this system. The first crackling experiments in wireless communication, the short beeps, the rough, shaky voices left Earth long ago. Those faint signals have already crossed Jupiter's orbit and moved on into deeper space. But later broadcasts are still arriving. Old songs, early television shows, calm newsreaders describing long-past events, cheering crowds at distant games. All of it stretches and thins as it crosses the billions of kilometers between Earth and the giant planet. Space, most of the time, does not answer. The waves spread, weaken, and sink into the quiet background hiss of the universe. They drift in the cradle of silence. At least, that is what we believed. On Earth, astronomers have listened to Jupiter for decades. In visible light, they track its spinning storms. In infrared, they trace warmth rising from its deep interior. In radio, they listen for the strange patterns made by its magnetic field and its moons. Huge metal dishes turn slowly across the sky, following the planet as it rises and sets, recording every small change. To study what they hear, scientists use an instrument called a spectrograph. It spreads radio waves out by frequency, much like a prism spreads white light into colors. On computer screens, the data appears as maps, bright and dark bands showing where the signal is strong or weak over time. Over the years, those maps become familiar. Certain streaks mean lightning. Other patterns mean charged particles spiraling along magnetic field lines. Some signatures come from Jupiter itself, some from its moons, some from the stream of particles flowing outward from the sun. Most of the time, the graphs look wild and messy, like storms drawn in lines. Then, during one quiet stretch of observation, something different appears. It is small, easy to miss. A thin curved mark shows up near the edge of a spectrograph image, in a place where almost nothing is usually seen. It does not flare. It does not repeat right away. The computer records it and moves on. Later, a researcher reviews the data. Their task is simple but careful. Check times, clean noise, make sure the instruments behaved. They scroll past line after line of plots and numbers. The odd curve almost slips by. Almost. For a heartbeat, the shape holds their eye. It rises and falls with a rhythm that feels different. Not like random noise. Not like the jagged, chaotic marks of Jupiter's stormy radio voice. It is smoother, more regular. Like a quiet whisper that almost becomes a word, then breaks off. The researcher marks it. Other members of the team look more closely. They check the equipment logs. They check the weather over the observatory. They search for simple causes. A radar beam nearby, a passing satellite, a brief glitch in the system. Every ordinary explanation is tested. The lines stay strange. Its frequency lies in a band humans have used heavily for their own broadcasts. And when someone traces back the timing, how long a signal would need to cross the space between Earth and Jupiter and return, a fragile idea appears at the edge of the conversation. What if it is an echo? Not a clear reply. Not a neat reflection. Just a faint, bent piece of energy that started on Earth, touched something near Jupiter, and then found its way home again. It is an idea that could crumble under a little pressure. The team knows that. Radio data is tricky. Minds are quick to see patterns where none exist. So they do what careful scientists always do when they meet a mystery. They ask for more. More observations. More checks of older recordings. More careful attention to small, odd curves near the edge of the usual noise. Dishes turn toward Jupiter again. Software is tuned to listen just a little more closely. Meanwhile, Earth keeps talking. Every moment, new signals leave the planet. GPS pulses timing the world. Satellite links carrying information, streams of music and video, short messages sent from one pocket to another. Even as you lie still and listen, the air around you is full of signals you will never feel. They pass through walls. They cross oceans. They rise through the thin upper air. Above the last breath of atmosphere, they slip free and join the older waves already on their way. Layer by layer, year by year, the radio bubble grows. In this invisible light, Earth becomes a tiny artificial star. Far beyond all of that, the signals keep going. Past the Moon, past Mars, through the asteroid belt. Again and again, they cross the orbit of Jupiter, brushing the giant planet and the paths of its circling moons. Some of our very first radio waves are already much farther away, racing toward the dark space between the stars. They will travel on for ages, growing weaker, but never truly stopping. The region around Jupiter remains a kind of edge. Close enough to study, strange enough to surprise. Its moons may hide oceans. Its magnetic field carves invisible rivers of energy through the thin solar wind. And somewhere inside stacks of data, inside quiet graphs and saved files, there is still that small, curved mark. Maybe it was a tired instrument, drifting slightly out of tune. Maybe it was a burst from some restless corner of Jupiter's atmosphere. Maybe it was a tiny piece of rock or ice, reflecting our broadcast for a brief moment before tumbling away. Or maybe it was something else. For now, no one can say. Above the sleeping cities, towers keep sending their invisible light. Beyond the clouds, radio waves keep climbing and drifting outward, carrying songs, news, and whispered calls into the deep silence. And out there, near the giant planet and its circling moons, the first faint murmurs of an answer seem to wait just beyond our hearing. Resting in the dark for minds patient enough to listen, the night is quiet over the turning Earth. Cities dim their lights one by one, and the sky above grows darker and wider. Far from streets and traffic, on empty fields and lonely hilltops, dim metal towers rise into the air. Wires stretch like bare branches against the stars. Old antennas stand motionless in the dark, as if they are listening to something most people cannot hear. At first, they are simple tools. Wooden masts, copper wires, heavy boxes full of coils and warm glass tubes. In small rooms that smell of dust and solder, early radio builders lean close to their work. Fingers turn rough dials with slow care. Ears press against padded headphones. They do not yet think of space. They only hope to reach another town, another ship at sea, another human being somewhere beyond the horizon. On these first nights, the sound is mostly static. A soft hiss like distant rain on empty streets. A dry crackle like a tiny storm trapped inside a wire. Then, hidden under the noise, come small, sharp clicks. Morse code. Short and long pulses of radio light, too quick for the eye, but clear to anyone who learns the rhythm. Across oceans and over mountains, those pulses leap. They bend and bounce along the thin blue shell of air that wraps the planet. Each dot and dash is a human voice turned into pure pattern, simple, fragile, and full of meaning. A ship at sea sends out a call. A station on land answers. Between them, invisible waves stretch and fold, wrapping the planet in a thin, growing web of energy. Humanity has built its first quiet bridge made only of signal and sky. Night after night, more radios wake up. New antennas rise on rooftops, on naval decks, beside train lines. Telegraph keys click. Soon, voices follow. Radio carries not only code now, but music and speech. A song drifts out across a sleeping town. A newsreader tells of distant events to people gathered around a wooden box. Somewhere in the dark, a child listens and wonders how a voice can cross so much empty space. With every new station, the web around Earth thickens. The planet begins to wear a fragile halo of radio, like a soft veil of starlight that only the right instruments can see. Each broadcast races outward at the speed of light into the space between worlds. Most waves are bent back toward the ground, trapped and guided by the layers of our atmosphere. But some slip through. They escape. Those escaping signals are the first true messengers to the stars. If you could float far above the planet past the orbit of the moon and look back with radio-sensitive eyes, Earth would not be silent. The blue world would hum. Thin bands and broad sheets of energy would pulse around it, each one carrying a tiny fragment of human life laughter buried in static. Brief, clear notes of music, numbers, warnings, prayers, and noise. To anyone listening from far away, our world would sound restless and curious. Decades pass. The technology changes, but the idea stays the same. Radios become smaller. Their parts shift from glowing tubes to quiet circuits. But the antennas grow larger. Great white dishes bloom in deserts and high plateaus, their curved surfaces turned carefully toward the sky. In control rooms lit by the soft glow of screens and dials, engineers and astronomers guide them, not just across the Earth, but away from it, into the deep. Radio turns into a bridge between worlds. Some dishes point at the moon, others at distant stars, nebulae, and the faint hiss of the universe itself. And some of the largest, again and again, turn toward a bright wandering point in the night sky, Jupiter. Jupiter moves slowly along its wide orbit, a giant sphere of cloud and storm. Charts tell where it is even when it cannot be seen. It glides along its invisible trajectory like a pale lantern far beyond Mars. To the eye, it is only a point. To a radio telescope, it is something else entirely. Jupiter is loud in radio. Long before our own signals reach it, the planet sends out its own voice. Bursts of radio noise stream from its powerful magnetic field. Lightning crackles deep inside its clouds. Its moons cut through invisible belts of charged particles like stones through a river, stirring up waves and swirls of energy. When these waves wash past Earth, a radio dish can turn them into sound. The rush of surf, a rising whistle, or a tearing hiss that seems to come from nowhere at all. Scientists learn to read these sounds like weather. They record them as lines and curves on long strips of paper. Later, they store them as streams of numbers inside quiet rooms full of humming machines. They watch how the noise changes as Jupiter rotates, as it swings closer to the sun, as its moons move in and out of shadow. One moon, a small, volcanic, and bright, becomes a special key. When Io is in a certain place in its orbit, Jupiter's radio emissions grow stronger and more complex, as if the tiny moon is pressing a hidden switch. The pattern is clear enough that some observers can guess the strength of Jupiter's radio storm just by knowing where Io is in the sky. All the while, human-made signals keep spilling outward. Television towers being steady carriers toward nearby homes and beyond. Deep space networks send sharp beams toward robotic explorers at the edges of the solar system. Communication satellites bounce messages from ground to ground, yet a little of each transmission leaks out, missing the receiving dish and continuing straight into the dark. Over time, these leakages add up. Along Earth's orbit, a cloud of faint, tangled patterns forms, like the wake of a ship cutting through a black and silent sea. From far away, our planet is no longer only a world of oceans and continents. It is a world of waves. If you could stand on one of Jupiter's distant moons and listen with delicate instruments, you might sense Earth not just as a point of light, but as a source of thin, complex whispers. The signals would be weak, almost drowned by the sun and the giant planet's own storms. Yet they would still be there, tracing out the history of a noisy species that has learned to speak in radio. In quiet observatories back on Earth, people begin to wonder. If our signals can travel so far, then in time they will brush past other planets, other moons, other stones, and ice and dust. Some ask if anyone might be listening. Others ask a softer, stranger question. Might something already be talking, and we simply have not learned how to hear it? At first, Jupiter's radio voice seems simple. It roars, it crackles, it flares. It follows the spin of the planet, the pull of the sun, and the dance of its moons. But as instruments become more sensitive, as spectrographs grow finer and computers grow faster, tiny oddities begin to stand out against the familiar noise. In certain seasons, during certain alignments of Jupiter and its moons, the usual hiss seems to bend. Small gaps appear where there should be smooth static. Thin, sharp spikes rise where there should be gentle slopes. Now and then, bursts repeat with a neatness that does not quite fit the wild storm of a gas giant. Most of these puzzles are explained. Some traces come from our own machines, slipping into the data when a plane crosses the horizon or a satellite passes overhead. Some come from distant galaxies, bright for a moment as matter falls into hidden black holes. Others are simple errors, born from cables, warm circuits, and clocks that are not perfect. But not all of them. A few patterns return, quietly, over years. They are very faint. They do not shout. They whisper. They appear only when Jupiter is in a particular part of its orbit, or when one of its moons glides along a certain path. They hide deep in the static, like faint footprints pressed into drifting snow. Easy to miss and easy to doubt. Most scientists call them coincident shapes in random noise. The human brain is good at seeing patterns, they say, even when none exist. And most of the time, they are right. Still, a small group of listeners keeps watching. They adjust their antennas and receivers, tuning them to the exact frequencies where the odd patterns sometimes appear. They stack many nights of data on top of one another, letting random noise blur while anything steady rises gently into view. They filter out known sources of interference. They subtract the glow of the galaxy, the breath of the sun, the familiar roar of Jupiter's own storms. What remains is very small, a thin thread of signal woven into the larger sound. To most ears, it is nothing at all. Just a subtle change in the roughness of static. But to those who have listened for years, who know Jupiter's radio voice the way a sailor knows the moods of the sea, it feels different. Not human, not clear, but not as random as simple weather either. By now, the halo of Earth's radio noise has spread far beyond Jupiter's orbit. The earliest Morse code pulses, the first shaky voices, the old songs and news reports have all streamed through that distant part of space. They continue on, brushing past meteor streams in the perihelion arcs of lonely comets, skimming the thin tails of ice and dust as those ancient travelers swing close to the sun and then back out again. Our signals drift outward like an ancient traveler in a silent station, carrying stories no one has yet learned to read. On a calm night back on Earth, another observing run begins. Tall antennas tilt a little, following Jupiter's slow climb above the horizon. Computers hum softly. The air cools and settles. Stars sharpen in the dark sky. Somewhere between the noise of storms and the gentle background breath of the galaxy, a tiny change waits, patient and unhurried. The radios keep listening, their metal faces turned toward the giant planet and its circling moons. As if expecting that, at any moment, the random hiss of the universe might bend, just slightly, into something that almost sounds like a reply dot far beyond the soft blue disk of Earth. Past Mars and the cold stones of the asteroid belt, a giant hangs in the dark. This is Jupiter, a storm-wrapped fortress made mostly of gas, turning slowly in the deep. Through a telescope, it looks calm at first, bands of cream and rust circling its round face, the great red spot turning like an ancient eye. But this calm is only on the surface. Around Jupiter, space itself is loud. Jupiter is one of the strongest natural radio sources in our solar system. It does not just reflect light from the sun. It sends out invisible radio waves of its own. These waves are born in its powerful magnetic field, a field so wide and strong that if you could see it glowing, it would form a huge bubble, its magnetosphere, larger than the Sun. From the Sun, a constant wind of charged particles blows outward. This solar wind moves through the solar system like a thin, fast fog. When it hits Jupiter's magnetosphere, it bends and stretches it, squeezing it on the side facing the Sun and pulling out a long tail on the far side. As the magnetic field lines twist, snap, and reconnect, they release energy. Some of that energy becomes radio waves that spread through space at the speed of light. To a sensitive antenna, those radio waves sound like distant weather. There are sudden bursts of sharp crackles, long hissing sighs, and sometimes low, ghostly howls. Lightning on Earth makes its own radio sounds, but Jupiter's storms are far more powerful. Even across hundreds of millions of miles, the giant's voice can be stronger than our own planet's lightning. Astronomers first picked up these strange sounds in the mid-1900s, when radio telescopes began to listen to the sky. Great metal dishes, shaped like deep bowls, turned slowly to follow the planets. The signals they caught were turned into electric traces on screens, and sometimes into sound. Out of the background static, patterns appeared that rose and fell in rhythm with Jupiter's spin. The invisible fortress was speaking. Over time, scientists learned that Jupiter's radio storms come in different kinds. Some are smooth and steady, like the hum of an engine that never stops. Others are short and sharp, flashing on and off so quickly they sound like popcorn in a pan. Some follow the rotation of the planet, sweeping past at the same points again and again, like the beam of a lighthouse. Others are tied to activity near the poles, where the magnetosphere guides charged particles down into the atmosphere. Near Jupiter's north and south poles, those particles dive into the thin air high above the clouds. When they strike atoms and molecules there, they make them glow. This is how auroras form. On Earth, we see them as the northern and southern lights. At Jupiter, the auroras are larger and brighter, forming glowing rings that shine mostly in ultraviolet and infrared light colors our eyes cannot see, but our instruments can. Imagine drifting far above one of Jupiter's poles in the cradle of silence between the stars. Below you, the planet fills your view, banded with slow rivers of cloud and dotted with spinning storms. Around the pole, a permanent auroral ring flickers and shifts like a soft, ragged crown of light. Each flicker marks the path of particles sliding along magnetic lines, falling in from space and giving up their energy as glow. The same motions that build these lights help create the radio storms. Electric currents race through Jupiter's magnetosphere, weaving around the planet and out along its tail. Plasma, a thin mix of charged particles from the solar wind, from Jupiter's own atmosphere, and from volcanic moons like Io, moves along the curved field lines. As Jupiter spins, it drags this plasma with it, turning the magnetosphere into a vast turning machine. Most of the time, the radio noise follows patterns scientists can explain. When the solar wind grows stronger, the magnetosphere shrinks and becomes more active. When it relaxes, the storms soften. Instruments on spacecraft and on Earth see the same curves and peaks, repeating like a familiar tune. Yet, if you study the data carefully, you begin to notice something else: small gaps between the notes. On a screen, these gaps appear as thin missing lines or quiet patches where a burst should be. In sound, they are brief silences between crackles and howls. Many of them are easy to understand. A tiny glitch in a receiver, a passing source of radio interference, a moment when the telescope is shifted, all can carve holes in the record. These are the normal scars left by instruments and by life on a noisy planet. But once those known causes are removed, a few anomalies remain. A burst that starts a little too early. A hiss that fades in an unexpected way. A faint pattern in a place where models predict almost perfect silence. These are not signs of anything dramatic, only thin threads that do not yet have a clear explanation. They are watched with quiet awe and with care. Here the story moves from what is firmly known to what is gently questioned. Scientists do not rush to wild answers. They compare observations from different telescopes and different years. They test new ideas about how Jupiter's magnetic field might be shaped, how plasma might flow, how changes in the solar wind might tug at the fortress walls. Often, a careful model shows that the anomaly fits into normal physics after all. Still, a few questions stay open. The feeling they leave is not fear, but a kind of respectful wonder. If Jupiter is already such a loud messenger shouting in radio waves, glowing in auroras, carving its presence deep into space, what else might be happening in its vast, hidden magnetosphere that we have not yet learned to hear? What we do know is already enough to stretch the mind wide. Jupiter's magnetic field near the cloud tops is many times stronger than Earth's. Its magnetosphere stretches millions of miles into space, breathing in and out as the solar wind changes, like a giant lung in the dark. In that breath, energy is stored and released in bursts of particles, in rippling auroras, and in roaring radio storms that race outward toward the distant stars. Sometimes those storms reach all the way to us. Strong bursts from Jupiter can be picked up by simple antennas on Earth. Amateur listeners, sitting alone in quiet backyards under the night sky, have tuned in to the planet's voice. In their headphones, it arrives as a gentle wash of crackles and sliding whispers, like distant surf hidden under static. In that moment, their equipment is linked to a world hundreds of millions of kilometers away. To fall asleep with such a picture in your mind is to feel space as both vast and near. You lie in your own room, under a familiar ceiling, but a part of your awareness is drifting far from home, listening to a fortress of storms wrapped in dark. Jupiter's science is real, measured, and carefully tested, yet the feeling it gives is close to dream. A reminder that even in a universe ruled by clear laws, there is room for awe. Around the giant and its circling moons, radio waves continue to rise and fall. Auroras burn in soft rings, and magnetic lines twist and seem to sing in silence. Between those steady patterns live the thin gaps and gentle anomalies, quiet places in the data where something does not quite fit. In those pauses, it is easy to wonder whether other signals passing near this fortress, perhaps even some of our own, are being shaped, bent or faintly echoed as they cross its restless field. And in that drifting quiet, as the roaring fortress turns through the dark, one can almost sense that something hidden is still moving through its storms, waiting with patient calm to be understood far from the warmth of the sun. Beyond the bright inner planets, the journey moves outward into the deep. It slips through a thin veil of dust and drifting ice and enters the wide realm of Jupiter. The giant planet hangs in the dark like a pale lantern, wrapped in cloud and storm, with 4 small points of light circling in a quiet sea of starlight. These lights are not distant stars. They are moons, Io, Europa, Ganymede, and Callisto. From far away, they look like beads on a string drawn around Jupiter's glow. Up close, each is a separate world with its own landscape, its own history, its own quiet mood. Io, the volcanic harbinger. Europa, the hidden ocean. Ganymede, the magnetic guardian. Callisto, the scarred, eternal witness. Together they move in a rhythm so steady it feels like a slow cosmic heartbeat. Io is the first to step into view. It orbits very close to Jupiter, so close that the planet's strong gravity stretches and squeezes it over and over, as if the moon were made of soft rubber. Inside, rocks bend and grind, and that endless pulling turns into heat. The heat breaks through the surface in fountains of molten rock and wide lakes of lava that glow like embers against the night. Farther out moves Europa. At first glance, it seems calm, even fragile. Its surface is a shell of ice, bright and smooth in places, broken and lined in others. Long, dark cracks cross the moon like the marks on an old map. There are few impact craters, which means the surface is young. Ice shifts, melts, and freezes again, slowly erasing the scars of old collisions and drawing new lines across the frozen crust. Beneath that crust lies a global ocean of liquid water, kept from freezing by Jupiter's steady pull. Tides flex Europa the way the moon moves Earth's seas, turning motion into deep, hidden heat. Far below the ice, vents on the rocky floor may leak warmth and chemicals into the dark. On Earth, life gathers around such vents, far from sunlight. So people look at Europa and quietly wonder what might drift in that unseen sea. Ganymede follows, the largest moon not only of Jupiter, but of the whole solar system, even wider than the planet Mercury. Its surface shows bright ice and darker, older ground, cut by craters and long ridges. But Ganymede's most unusual feature is something that cannot be seen with the eye. Deep inside lies a turning core of metal. That slow motion creates a magnetic field, a small shield around the moon, nested inside Jupiter's much larger magnetic bubble. Farther still, in a slow and stately orbit, drifts Callisto. Its surface is crowded with impact craters, layer upon layer. Some are fresh and sharp. Others are worn and faded, like ripples pressed into ancient stone. Almost nowhere is free of marks. Callisto does not hide its past. It carries it openly. Little seems to change there now. The moon is less a stage for new events and more a vast record, a time capsule that reaches back to the earliest ages of the solar system. Seen together from above, the four moons draw thin, glowing paths around Jupiter. Io, Europa, and Ganymede are locked in a pattern called a resonance. For every 4 times Io races around Jupiter, Europa circles twice and Ganymede once. Their gravity tugs on each other, keeping the pattern steady and their orbits slightly stretched. This clockwork dance feeds heat inside the moons. It keeps volcanoes burning on Io and helps hold oceans liquid within Europa, and perhaps deep inside Ganymede as well. All of this takes place inside Jupiter's vast magnetic field, an invisible bubble filled with fast-moving charged particles. The field scoops up gas from Io's eruptions and from the solar wind, turning the space around Jupiter into a storm of plasma. Particles race along unseen lines like beads on wires, curving in toward the poles of the planet and its moons, then flinging back out into the dark. Space here is not truly empty. It is a moving, humming river of invisible matter. As those particles move, they create radio waves, ripples in electric and magnetic fields that spread outward at the speed of light. Some waves are steady, like a constant, far-off hum. Others come in sharp bursts and slow sweeps, their tones rising and falling in patterns that can be turned into sound. When radio telescopes on Earth first listened to Jupiter, they heard these emissions as crackles and whistles, like distant lightning or strange underwater calls from a world without air. The four moons shape this unseen music. Io, wrapped in its thick cloud of charged gas, bends and sharpens the radio waves, making bright patterns that sweep past like turning searchlights. Europa and Ganymede pass through the same streams of particles. Their ice and rock act like lenses and mirrors, bending and scattering invisible currents the way glass bends starlight. Every orbit, every alignment, leaves a delicate mark on the signals that drift away into space, like fingerprints pressed into a flowing song. On a small blue world far from Jupiter, humans have been sending out their own radio waves for more than a century. Telegraph sparks, early broadcasts, news, music, and quiet voices all leak outward, weaker with every billion kilometers, but still moving. By now, some of these fragile shells of human sound have crossed Jupiter's orbit. Our broadcasts, thin and fading, cross the paths of Io, Europa, Ganymede, and Callisto as unknown travelers in the dark. Spacecraft that have flown past Jupiter carry receivers and magnetometers that listen to this complex environment. They map the shape of the magnetic field, measure the streams of charged particles, and record the changing radio patterns near each moon. Back on Earth, scientists sort through the data, lining up signals with orbits and positions, searching for steady rhythms and small breaks in the expected pattern. Most of what they find matches the rules of physics, from the way plasma flows to the way magnetic lines twist. Yet within the data, there are always a few notes that do not fit neatly. A pulse that arrives earlier than expected. A tone that holds steady when theory says it should slide. A repeating shape that seems to return, quiet but stubborn, as if it wants to be noticed. These oddities are not proof of anything beyond nature. They may come from small changes in particle density, from noise in instruments, or from processes not yet fully understood. Even so, people lean closer when something breaks the pattern. They replay the data, filter the noise, and search for hidden structure, wondering what might lie just beyond their current models. Could such patterns be carved by rock and ice alone, by tides in a hidden ocean, by the ringing of a buried magnetic shell, by cracks that open and close far below the surface? Or do they hint, however faintly, at something else, a secret written in the silence between the waves? The four moons do not answer. Io still erupts under a thin sun. Europa turns its cracked, bright face toward the distant stars. Ganymede's invisible halo shimmers inside Jupiter's magnetic sea, and Callisto drifts in its slow, patient orbit, a memory etched in stone. Radio waves rise and fall around them, some born from storms, some carrying the fading echo of human words. And in that drifting quiet, one can almost sense that another secret is about to reveal itself. The night begins like so many others, quiet, careful, and almost forgettable. Outside, the desert air is cold and thin, wrapping the radio telescope in a clear, dark sky. The great dish points toward Jupiter, a pale lantern hanging low above the horizon. Its moons are invisible to the eye from here, but the telescope is not looking with eyes. It listens. Inside the control room, the world shrinks to a pool of dim light. Monitors glow like tiny nebulae scattered across the walls. Soft fans hum. Cables rest in lazy loops on the floor. A half-finished cup of coffee cools beside a keyboard. The people here speak in low voices, as if afraid to wake something sleeping in the static. The radio telescope's stream of data scrolls down the main screen, line after line, a river of numbers and thin spikes. It looks almost like an ECG for the sky beats and pauses, noise and pattern. Most of it is random, the natural hiss of our universe. Cosmic background radiation, solar wind, electrical noise from Earth itself. To most eyes, it would seem meaningless. But tonight, one small section of that river has something strange hidden in it. At first, it appears as a faint ripple, a tiny extra rise above the baseline. A technician notices it only because they have stared at this screen so many nights that even a small change feels like a shout. "Can you zoom in on that segment?" Someone asks, pointing. The view tightens. The static turns into a jagged forest. Within it, there is a shape. Not a clear message. Not a sweeping beacon. Just a slight, repeated pattern, like a whisper caught between gusts of wind. The coordinates are checked again. The telescope is aimed along a clean trajectory, its beam passing close to the path of Jupiter and its moons. The anomaly seems to sit in that direction, somewhere among those distant worlds locked in their eternal orbit. They mark the time. They tag the file. They ask the computer to save the raw stream. No one is excited yet. The universe is full of tricks. In the control room, the light is turned down even further, so the screens stand out in sharper contrast. The static becomes a landscape the team knows well. They begin to do what astronomers always do when faced with a mystery. They try to rule it out. First, they check for local interference. Could it be a passing aircraft, bouncing a signal in just the wrong way? They scan logs of nearby flights. The skies are mostly empty. Could it be a satellite in Earth's orbit, echoing noise from another band? They cross-check known spacecraft positions, radios, and frequencies. The usual suspects circle overhead, but none line up cleanly with this moment and this direction. Then they turn to the sky's own usual suspects. Pulsars rapidly spinning neutron stars often stutter and flash with perfect rhythm. The team compares the pattern in front of them with known pulsar signatures cataloged over decades. Pulsars speak with steady, repeating beats that cut through static like a metronome. This anomaly is different. It is softer, less stable, like something half-formed. Not a lighthouse in the dark, but perhaps a flicker behind a curtain. They widen the time window. They look at data from minutes before and then minutes after. The pattern appears only in a narrow slice, a brief sigh in the noise. They try different filters. They subtract the expected background hiss, the gentle radio murmur of the galaxy. What remains is faint, but still there. A faint echo that seems to lean toward the orbits of the Jovian moons. Hours pass in the slow, gentle way they do in observatories. People shift in their chairs. Someone stretches, joints popping in the quiet. The air smells faintly of dust and electronics. Outside, the dish continues to track Jupiter across the sky, turning almost imperceptibly, its movement hidden behind the steady hum of machinery. On another screen, a simulation model runs. It shows the positions of the moons Io, Europa, Ganymede, Callisto, each one sweeping around Jupiter on its set path. The orbits look simple, like rings drawn in chalk. But behind those smooth lines are countless invisible forces. Gravity, magnetic fields, plasma flows in Jupiter's giant magnetosphere. Could it be plasma noise? Someone suggests. Jupiter is famous for its radio storms, its roaring auroras, its charged particles spiraling along magnetic lines like glowing beads on invisible strings. Lightning crackles deep in its clouds. Its magnetosphere stretches like a huge invisible bubble, brushing against the orbits of its moons. They feed this idea into their tools. The spectrograph view shows how the signal spreads across frequency. Natural events often create broad, messy lines. Human-made signals tend to be sharp and narrow, like a single thread in a tapestry. The anomaly sits somewhere in between, more ordered than a storm, less precise than a machine. A boundary case. Most nights, mysteries fade under this kind of attention. Data that seems strange at first usually turns out to be a glitch in a cable, a gust of ionized gas, a satellite waking up for a scheduled transmission. With patient study, the unexplained becomes the explained. The anomaly becomes a note in a log, a short story with a clear ending. Tonight, the story refuses to end so easily. The team runs another comparison, this time against archived data. They ask the computer to search for any past nights where a similar pattern appeared, especially when the telescope pointed near Jupiter. The search churns quietly while the room waits. Outside, the sky slides slowly overhead. Stars drift across the narrow slit of the roof opening. An ancient comet somewhere far out continues its journey. An exoplanet circles a different star, unknown and unseen. Space carries on in its cool, indifferent way, while a handful of humans lean closer to a glowing screen. The computer finishes. The results show very little. There are a few rough matches, but none that align as closely in place, time, and shape as this one. The anomaly is not a regular guest. If it has appeared before, it has done so rarely and only in faint traces. Again, the team checks their instruments. They test the cables and the receivers and the software that cleans the data. They run diagnostics that fill the screens with solid blocks of color and thin horizontal lines in perfect order. The equipment behaves as it should. No obvious error. Steps forward to claim the blame. What remains is a quiet, shared uncertainty. If you were there, in that room, you might feel it too, the sense that something just beyond understanding had brushed past your awareness. Not a shout, not a clear message, just a nudge. They print a small section of the data. On paper, it looks even more fragile, a thin band of noise with a slightly repeated rise and fall. Someone circles it with a pen. A handwritten note appears in the margin. Unusual pattern, near Jovian moons. Recheck. No one writes proof on the page. No one dares to even think that word. The history of astronomy is full of almost messages and almost discoveries. A telescope moves slightly. A clock drifts by a fraction of a second. A signal from Earth bounces around the atmosphere and tricks a receiver meant for the stars. The lesson has always been the same. Be careful. Be patient. Still, the pattern lingers in their minds. They imagine different explanations. Maybe a small piece of space debris, following an odd trajectory, scattered radio waves in a particular way. Maybe a brief, sharp event in Jupiter's magnetosphere, a knot of plasma turning and untangling. Maybe some unknown interaction between a moon and the charged particles surrounding it, creating a momentary radio note in the dark. Or maybe a quieter thought suggests it is something else. The idea is not spoken out loud for a long time. It floats silently inside each person's mind like a drifting shadow. What if this faint echo is not just a side effect of nature, but a shape made by something adapting, responding, or learning? Not a full conversation, not yet, but the first slight bend in a line that once was straight. The anomaly itself does not answer. It plays out over those few seconds and then is gone, swallowed back into the endless static. The telescope continues listening. The sky continues humming. The receivers gather hour after hour of clean, ordinary data. The team saves everything. They back it up twice. They mark the observation logs, so anyone reading them years from now will know something odd happened here. This is how science remembers, not with a single dramatic moment, but with careful notes that say, "Look here again." Later, when the room has grown even quieter and the night leans toward morning, someone replays the anomaly as sound. The signal, shifted into the range of human hearing, becomes a soft, crackling murmur. Within it, the repeated pattern is a tiny pulse, like a distant heartbeat muffled under layers of noise. They listen in silence. No one speaks for a while. If you were listening too, eyes closed, you might imagine that somewhere near Jupiter, near the cold surfaces of its moons or the invisible flows between them, space itself had cleared its throat. Just once. Just enough to be noticed by those paying close attention. The recording stops. The speakers return to a low hum. What remains is not an answer, but a question. Is this nothing more than a trick of plasma and trajectory? A coincidence born from gravity and charged particles? Or is it the first hint that the moons of Jupiter, shaped by oceans of ice, stone, and invisible forces, are beginning to leave their own faint marks in the radio night? For now, no one knows. The data is filed, the lights in the control room dim even further, and some of the scientists lean back in their chairs, letting their eyes rest. The telescope outside continues to sweep its beam along its path, tracing invisible arcs across the sky. In the great cradle of silence that surrounds Earth, the anomaly becomes a memory small, fragile, persistent. It does not demand belief. It does not erase doubt. It simply exists, a tiny wrinkle in the fabric of noise, waiting for the night when someone will see its shape again. And as the last monitor glow softens against the dark, it is easy to feel that the universe has turned just slightly toward us, leaving behind a single, quiet whisper that is yet to be understood. The story drifts outward now, riding on a river you cannot see. From the glowing face of the sun, a steady stream of tiny particles rushes into space. This is the solar wind, a breath that never stops, flowing in all directions at once. Each particle is smaller than dust, but together they shape the space between worlds. They slip past orbiting planets, wash over moons, and glide through the paths of old comets, trailing along every hidden trajectory. If you could float here, in this gentle storm, you would not feel wind on your skin. There is almost nothing here, just a few lonely particles in a huge empty sea. Yet over millions of miles, those particles matter. They carry the sun's faint touch, a distant warmth that reaches far beyond Earth. The night around you would look calm and black, but the space itself is alive, full of motion and quiet activity. As this solar wind moves outward, it brushes past our planet. It bends around Earth's magnetic field, sliding along invisible lines that curve from pole to pole. Auroras shimmer as some of the particles fall into our sky, painting the darkness with soft glow and drifting curtains of green and purple. Our satellites, space telescopes, and long radio antennas stand in this moving ocean, quietly feeling its subtle push. Farther out, the stream grows thinner, but it never truly fades. It keeps going, reaching the giant of our system, Jupiter. On the way, it passes Mars and the asteroid belt, slipping through fields of rock and dust, never stopping. The solar wind wraps itself around Jupiter like water around a stone in a river, changing shape but always flowing. Jupiter does not meet this wind as a small world. It stands as a giant fortress, surrounded by an enormous invisible bubble, its magnetosphere. This magnetic field is so large that if you could see it, it would stretch wider than the sun itself. Spacecraft flying through this region find it full of charged particles, spiraling and bouncing like fireflies trapped in glass. Inside this vast bubble, the solar wind is slowed, bent, and sometimes even pushed aside. Here, in this strange space around Jupiter, our own signals drift in. Long ago, humans began sending radio waves into the sky. Some went out by accident, like the first radio and television broadcasts. Others were sent on purpose, beams from large dishes aimed at distant spacecraft. These signals travel in straight lines, but space is not empty and simple. When they meet magnetic fields and clouds of charged particles, they twist and change. The region around Jupiter is full of such clouds. Electrons and ions race along magnetic lines. Lightning flashes deep in the planet's thick atmosphere, sending its own radio noise into space. The moons move through this field, each an island in a stormy sea. Io, covered with volcanoes, throws out material that becomes part of the plasma around the planet. Europa, Ganymede, and Callisto glide in their orbits, wrapped in a delicate dance between gravity and magnetism. Our radio waves, faint but steady, pass through this busy space. Some scatter when they hit thin wisps of gas. Some reflect off layers of charged particles, bouncing in new directions. Others bend, like light passing through water, their paths slowly curving. A simple signal, sent from Earth as a clean tone or a short, sharp pulse, enters Jupiter's magnetosphere and becomes something more complex. It might stretch, echo, or split into patterns. To picture this, think of waves on a lake. Throw a stone into calm water, and ripples spread out in circles. But if the lake already has waves, the new ripples mix with them. They overlap, add together, or cancel out. The surface becomes a lace of moving shapes. In space, radio waves act in a similar way. Instead of water, they move through plasma, a thin, charged gas, an ocean of particles guided by invisible fields. In this environment, waves can meet and merge. A single tone can break into a gentle hum, a rising whistle, or a hiss of noise. Spacecraft that have flown near Jupiter have listened to these sounds, turning radio waves into audio. The results are strange and haunting. Whistles that climb and fall, bursts of static like distant storms, and long, low moans that sound almost like voices not yet formed into words. It is easy, in the quiet of night, to imagine meaning in these shapes. If you sit by a radio receiver tuned to Jupiter's emissions, you might hear those rising notes and wonder if they hide a message. Could the magnetosphere, with all its swirling motion, carve our signals into something that looks like a pattern, a secret omen in the noise? Could a simple broadcast from Earth, after crossing millions of miles and passing through storms of plasma, arrive somewhere else sounding like a coded whisper? Nature often creates patterns that look planned. Lightning makes regular bursts. Some stars send out pulses so steady they once seemed like artificial beacons, sweeping past nebulae and distant exoplanet systems. Even the way galaxies cluster can trace out shapes that feel meaningful. Our minds are built to find order, to search for messages. In the cosmic static, we hear hints of something waiting, even when it is only chance. In Jupiter's magnetosphere, this search grows even more interesting. The moons move like small islands in a restless ocean, their orbits carving paths through the field. As they travel, they disturb the plasma around them. Waves ripple outward. Some of those waves mix with radio signals coming from Jupiter itself. Others meet the signals we have sent, bending them into new forms. To an observer far away, these blended waves might look like a strange, shifting code. Picture the scene: a dark sky with Jupiter hanging like a striped lantern, its bands soft in scattered starlight. The Galilean moons line up, tiny beads of light in slow, steady motion. Beyond them, the solar wind flows on, thin and wide, like a gentle veil stretched across the solar system. Every particle carries a bit of the sun's story, while every wave, from lightning or from human technology, rides along on this moving backdrop. The surfaces of the moons glow faintly, lit by reflected light from Jupiter and distant stars. Europa's ice turns this light into a quiet shimmer. Callisto's cratered face holds the memory of impacts older than human history. Ganymede, with its own magnetic field, stands as a small world with a complex inner life. Each moon is a possible archive, a place where signals might be altered or stored in subtle ways, in thin atmospheres, in charged dust, in the steady rhythm of currents below the ice. As the solar wind continues its long journey, it pushes past Jupiter and the outer moons, heading toward the colder worlds beyond. Our story, for now, lingers in the space around the giant planet and its companions. Here, the solar wind, the magnetic fortress of Jupiter, and our fragile signals all meet and mingle. Waves bend and scatter. Noise becomes pattern, then fades back into silence. The moons drift like ancient travelers through this charged sea, their frozen surfaces hiding worlds beneath. Beneath those icy shells, far from the touch of starlight, dark oceans are thought to wait in their own cradle of silence. The storms above send down their energy, subtle and slow, stirring what lies below. No one yet knows what stories those hidden waters hold, but in the quiet between the waves, one can almost feel that something down there is listening, beneath the frozen faces of Jupiter's moons. There is no sunrise and no sunset, no open sky at all. There is only ice, and below it, an endless night. Yet in that darkness, something moves. Slow currents, drifting minerals, and perhaps the first quiet stirrings of life. From above, Europa looks like broken glass. Its surface is covered in long cracks and ridges. To a spacecraft camera, it is a world of scars, but to scientists, those scars are clues. They suggest that Europa's ice crust does not sit on solid rock. Instead, It may float on a global ocean of liquid water, hidden beneath miles of ice. This picture comes from gravity and motion. Europa's orbit around Jupiter is not a perfect circle. It is slightly stretched, so the distance to the giant planet is always changing. Jupiter's gravity pulls harder, then softer, over and over. With each orbit, Europa is flexed and squeezed. Inside, ice and rock bend and grind, turning motion into heat. This gentle warming tidal heating may keep a deep ocean from freezing solid. Even so far from the sun, far below the cracked plains, there is no starlight, just a faint warmth rising from the interior. If you could sink through the ice, you would pass layer after layer, white fading to gray, then to black. And then the world would open into a vast, dark sea, perhaps tens of miles deep, wrapping all the way around the moon. In that ocean, the pressure would be immense. Water would press in from every side, a heavy, endless embrace. There would be no waves, no winds, only slow, drifting currents shaped by heat and salt. Somewhere on the rocky seafloor, warm vents might pour out mineral-rich water. On Earth, such vents act as cradles of life, where bacteria and pale animals live off chemical reactions instead of sunlight. On Europa, scientists imagine something similar. They picture hot spots on the seafloor, where tidal forces melt rock and drive undersea volcanism. Around those vents, thin films of microbes could cling to minerals. Simple cells might drift in the gentle flow, feeding on chemical gradients and copying themselves, generation after quiet generation. Farther from Jupiter, Ganymede hides its own secret sea. Once thought to be a frozen giant, it revealed another story when scientists studied its magnetic field and gravity. Beneath Ganymede's ice, there appears to be a deep ocean, or even several stacked layers of water and ice. Some models suggest solid ice that behaves like rock, with liquid water trapped between frozen sheets. Where Europa's ocean may rest on warm rock, Ganymede's seas might be sealed between thick slabs of ice, like pages pressed in a book. If life exists there, it will be buried even deeper, hidden behind miles of frozen crust. Yet the same push and pull of orbit and gravity could still stir those waters, keeping them from turning into a silent, solid core. These hidden oceans are not lit by suns, but they are warmed by motion. They do not sparkle with reflected light, but they move with quiet energy. They are places where a liquid water may last for billions of years. And time, for life, is as important as warmth. With enough time, even simple chemistry can begin to build something more. When scientists look at Europa and Ganymede, they are not just staring at icy moons. They see natural laboratories for a larger question. Is life common in the universe, or is it rare? A fragile accident that happened only once, here on Earth. Our own oceans cover most of our planet and hold ecosystems from bright reefs to deep trenches. If life can adapt to Earth's deepest, darkest waters, why not to the black seas of another world? Far beyond Jupiter, telescopes study distant exoplanets orbiting other stars. Astronomers watch for tiny dips in starlight as a planet passes in front of its star, tracing its orbit and its size. With spectrographs, they split that starlight into colors, searching for faint fingerprints of gases in alien atmospheres, water vapor, methane, perhaps even oxygen. These signs suggest that an exoplanet might hold oceans, clouds, or even living processes at work. When they imagine those far-off worlds, they often think back to Europa and Ganymede. If our own solar system can hide oceans beneath ice, then countless exoplanets might do the same. Some may orbit cool red dwarf stars, held close by strong gravity and fierce tides. In such systems, tidal heating could be the unseen engine that keeps buried seas from freezing. The galaxy may be full of worlds locked in endless night, their surfaces frozen like glass with warm, salty oceans swirling in the dark below. Here, the question becomes more personal. If life exists in those buried oceans on Europa, on Ganymede, or on a distant exoplanet, what would it feel? A microbe has no words, yet it senses and responds. It moves toward food, away from harm. Over time, such simple sensing might grow into patterns of behavior, fragile networks, perhaps even complex ecosystems balanced in the dark. Imagine not just microbes, but larger, softer shapes, pale, translucent creatures with slow, careful motions gliding through black water like ghosts. They might sense pressure, vibration, or faint electric fields. They could live their whole lives without ever seeing a star, never knowing that above their icy roof, a giant planet shines and tiny spacecraft sweep past like silent comets. Now imagine that, one day, a signal reaches them. Maybe it is not a sound they can hear or light they can see. It might be a burst of heat from a probe melting its way through the ice, a new pattern of chemicals released into the water, or a weak electric hum where none existed before. To them, it would be an anomaly, an unexplained flicker in the deep. A cosmic whisper from above, carried down through miles of ice. If such beings could feel anything like what we call emotion, would this strange presence bring fear or hope? Would it seem like a harbinger of danger, or a messenger from somewhere beyond their world? Would they flee from the disturbance or draw closer, the way we aim our telescopes at any unexplained signal in the sky? From our side, we are already preparing the first quiet greetings. Spacecraft measure the thickness of the ice. They map the cracks, study the orbits, and watch for plumes of water spraying into space, tiny leaks from the oceans below. Each bit of data shapes the plans for future missions, for landers and probes that may one day drill or melt their way through the crust and taste the water directly. As you listen, it may be night where you are. Perhaps your room is dim, your world quiet. Above you, though you may not see it, the sky is wide and deep. Somewhere up there, Jupiter moves along its orbit, trailing its moons like a tiny system of worlds. Their icy shells are turned toward the darkness, hiding oceans that have never known the light of day. In those oceans, if life swims, it does so in a cradle of silence, unaware of our questions and our instruments. It does not know about orbits or spectrographs or exoplanets. It knows only the slow rhythm of tides in the dark, the steady pull of gravity, and the chemical flavors of its world. Yet still, we wonder if, in that endless night, there exists even the faintest spark of awareness, and if the first touch of a probe will one day reach those hidden seas. For now, the oceans of Europa and Ganymede remain sealed, their stories locked beneath miles of ice. They turn in quiet paths around their giant planet, carrying their secrets through space. And in that drifting quiet, one could almost sense that another secret is already rising toward the surface, waiting for the moment when the ice will finally yield, and the darkness will meet the light. Far from the bright blue of Earth, Jupiter hangs in space like a softly glowing lantern, banded with storms and wrapped in a pale veil of cloud. Around it, 4 bright moons trace quiet paths, each one a tiny world with its own scars and hidden stories. To the eye, they look like simple points of light drifting back and forth. But beneath that slow motion is a strict pattern, a steady pull of gravity and distance that turns the outer darkness into a gentle, ticking machine. Every moon follows an orbit, a curved path carved out by Jupiter's pull and the tug of its neighbors. Io, Europa, Ganymede, and Callisto move at different speeds, each circling with calm loyalty. Io rushes closest, racing around the planet in less than 2 days. Europa glides behind it, taking a little longer. Ganymede and Callisto move in wider, slower loops like dancers farther from the center of a stage. Fast, slow, slower still, their paths form a repeating rhythm that echoes over days, years, and centuries. If you could watch them from high above the planet, their motion would look like a drawing made of light. Fine arcs cross and recross in perfect order, never colliding, never truly wandering. Each moon has a future position that can be predicted with almost casual ease. Tomorrow, next month, 100 years from now. This reliability is more than beautiful. It is useful. It lets astronomers choose their moments, turning this cosmic choreography into a schedule for watching and, more importantly, for listening. Because when moons move, shadows move too, and shadows change what can be seen. Jupiter is huge, more than 1,000 times the volume of Earth, and it casts a long cone of night into space. As its moons circle, they sometimes slip behind the planet and vanish into that darkness. At other times, they cross in front of Jupiter from our point of view, threading across its face like tiny beads of ink drifting over swirling clouds. These events, eclipses, and transits are the quiet ticks of a celestial metronome. One moment, a moon is bright against the black of space. The next, it is gone, swallowed by shadow or drowned in the planet's glow. Each of those moments changes not only the light we see, but also the signals we might detect. When a moon slides into Jupiter's shadow, its sunlit surface is plunged into sudden night. Reflected sunlight disappears. The cold, icy shell of Europa or the volcanic plains of Io go dark, hidden behind a soft, shifting veil. For a while, that world becomes nearly invisible to our ordinary eyes. Any glint, any flicker on the surface that we hope to study is simply not there. We wait until the orbit carries the moon back into the light again, like a spotlight returning to a quiet stage. Yet light is only one way to see. In other parts of the spectrum, the story continues. Jupiter is a natural radio beacon, sending out bursts and hisses of energy from its powerful magnetic field. Some of these emissions are shaped by the moons themselves, especially Io, which drags charged particles through the field like a wire moving through an invisible engine. When the moons line up just right, these natural radio signals grow stronger or weaker, rising and falling like notes in a strange cosmic song. Down on Earth, radio telescopes turn their great dishes toward the system, listening for those changes and learning how the orbits play the music. The same geometry that shapes natural signals could also shape any artificial ones. Imagine a distant listener, perhaps on or above one of these moons, tuning an antenna to our broadcasts, those faint bubbles of radio and television, spacecraft commands and radar pulses, all drifting outward from Earth. Most of the time, our signals are weak, spread thin as they cross the cold space between worlds. But there are moments, brief and special, when the angles line up just right. A moon may sit at the perfect point in its orbit for a signal to skim across its surface, reflect off ice or a thin wisp of atmosphere, and bounce back toward our planet. In those moments, the orbit acts like a door that is quietly swung open, just for a while. Astronomers already use this idea in a simple, practical way. When a spacecraft passes behind a planet or moon, its radio link to Earth slowly fades, disappears, and then returns as it comes back into view. By studying how the signal dims and brightens, scientists can learn about the atmosphere it passed through and the shape of the object blocking it. This is called a radio occultation, a shadow not of light, but of communication. The same effect, in theory, could reveal a hidden pattern or a strange echo in the radio noise around Jupiter. To find such things, timing is everything. Because the moons move with such steady regularity, we can predict exactly when one will pass into shadow, cross in front of the planet, or stand off to the side, alone against the dark. Each configuration creates a different kind of window. When a moon passes in front of Jupiter, it might briefly block some of the planet's loud natural radio emissions, acting like a shield and creating a tiny pocket of quiet where a faint, unusual whisper could stand out. When a moon slips behind the planet, Jupiter itself blocks that entire side of space, closing the window completely. There are also moments when a moon is far from Jupiter's glare, drifting through a calmer patch of sky. During those stretches of orbit, the icy surface of Europa or the ancient crater fields of Callisto are lit by a softer, more even glow. Jupiter is off to the side, not directly behind, not directly in front. From Earth, the line of sight is cleaner. Any signal rising from that moon or reflecting from its surface has a clearer path to our waiting telescopes. The background is quieter. The metronome of orbits has reached a point where the noise dips and the listening becomes just a little easier. On Earth, the listening is patient and slow. In remote deserts, on high mountain plateaus, and deep within quiet valleys, radio telescopes tilt their dishes toward Jupiter and its moons. They move smoothly, almost silently, following trajectories calculated long in advance. Computers keep careful track of the times when Io is expected to trigger bursts, when Ganymede will slip into eclipse, when Europa will stand most alone in the sky. At each of those moments, data flows in a steady stream, later sifted and studied for patterns that cannot be explained by storms, magnetic waves, or the sun's own restless breath. Most of what they find is perfectly natural. Spikes of noise from Jupiter's magnetic field, gentle rises and falls as a moon enters or leaves eclipse, occasional flares from our own star, washing across the sensors like a gust of static. It is a complicated, shifting song, but it is a song we are learning to read. The more we understand this clockwork dance, the timing of every shadow crossing, the strength of every ordinary emission, the better we become at noticing anything that does not belong. And if something did not belong, it would stand out like a wrong note struck in a familiar melody. This is why the orbits matter. They are not just lines on a chart or dots on a screen. They are a schedule the universe keeps with quiet discipline. Every eclipse, every alignment, every drifting shadow is an appointment that will be kept, whether or not anyone is there to watch. For anyone human or otherwise trying to send or receive a message within this system, those appointments are chances. Open doors. Brief gaps in the noise when a carefully timed signal might travel the farthest and shine the most clearly. The orbits will continue whether or not that answer ever comes. Jupiter will spin. Its moons will rise and fall, slipping into shadow and returning to the light as they have for ages. The metronome will keep ticking calm and timeless. And here on Earth, beneath our own restless sky, we keep sending signals into the dark, trusting that somewhere in that vast clockwork dance, there might be a moment when our message and a listener quietly meet. In that drifting quiet between eclipses and alignments, the universe feels a little less empty, as if the silence itself is waiting to be understood. The world outside is asleep. City lights fade into a dim glow. Clouds drift like a gentle veil, and somewhere beyond them, radio dishes turn in slow, careful arcs. In a quiet control room, far from the noise of daytime, a handful of people sit awake, listening to the sky. Screens cast a soft glow on tired faces. Headphones rest on shoulders. Fingers hover over keyboards, waiting for numbers to change. There is no loud music, no dramatic countdown, just the constant hum of machines and the quiet breathing of people who have chosen to stay up with the stars. They watch streams of data scroll past, green or white against black. To most eyes, it would look like nonsense. Lines of numbers. Spikes on graphs. Tiny peaks that rise and fall like the outline of a distant mountain range. But to them, any small anomaly could be a cosmic whisper. For decades, humans have been sending our own signals outward. Old TV shows, early news broadcasts, the first crackling words bounced off the ionosphere and escaped into space. With every year, our bubble of radio noise grows larger, racing away at the speed of light, brushing past comets and planets in their long orbits. These transmissions are not neat, polished messages. They are more like the glow of a campfire seen from far away, a sign that something warm and busy burns in the dark, a sign that someone is home. Even when we are not trying, the earth itself becomes a beacon, shouting into the cradle of silence around it. But sometimes, humans do try. Special beams from giant radio telescopes are aimed with care, like flashlights pointed into an endless night. Simple patterns of numbers are encoded and sent, arranged in ways that might reveal logic, counting, or the shape of a human body. Messages built in the hope that a stranger, very far away, could understand. These projects are technical, yes, but they are also deeply emotional. Underneath the equations lies something fragile: loneliness. The sense that our planet is a small, bright island in a vast, dark ocean. When we send a signal, we are not only asking, "Is anybody out there?" We are also quietly saying, "We are here. Please see us." In late-night halls of observatories, that feeling is almost physical. Coffee cups sit half-finished beside notebooks. Someone rubs their eyes and leans back, listening to the hum of cooling fans. Another rechecks a line of code, making sure the telescope is pointed exactly where it should be, following the trajectory of a nearby star or distant exoplanet. The search for extraterrestrial intelligence, SETI, lives in these rooms. It lives in the cables, the spectrographs, the recordings of radio waves collected from across the sky. The people here know that most of what they capture will be natural. Pulsars beating like ancient lighthouses. Nebula clouds breathing in slow, drifting patterns. Radio noise from our own planet, leaking upward like steam. Still, they look for patterns that do not belong. A pulse that is too regular. A tone that holds steady while a telescope tracks the spin of the Earth. A narrow signal, sharp and clear, sitting out from the background like a single voice in a crowded room. Over the years, a few such signals have appeared. They rise and disappear, leaving behind only questions and a thin trail of data. Most are later explained. A human satellite, a piece of electronics, a reflection from the moon. But a few remain stubborn, like memories you almost understand but cannot fully recall. The strange signal near Jupiter's moons belongs to that small, unsettling group. At first, it is just another spike on a routine scan, a narrow line at a certain frequency, picked up when a radio array sweeps past the giant planet and its icy companions. The observatory team tags it, logs the time, notes the angle and the tracking path. It might be nothing. Almost everything is nothing. Yet something about it feels different. It is oddly clean, like a pure note played in a room full of noise. It appears not just once, but again during another pass, when the telescopes glide along the same trajectory. The data shows it clearly, a thin, bright mark near the domain of Jupiter, where moonlight and radiation dance together in a restless orbit. Scientists compare it to known sources. They check catalogs of human satellites, deep space probes, and the radio chatter from Earth's busy machines. They sort through the usual suspects: reflections, interference, software glitches. Piece by piece, they peel away the obvious answers, like layers of an onion. Underneath, the signal waits, unexplained. In this quiet, the work becomes almost meditative. You can imagine yourself in that room, watching the graphs, hearing the soft clicks of keyboards. Outside, the night stretches over mountains and oceans. Inside, the question grows. If this is not us, and not a known natural source, then what is it? There is no bright flash, no decoded message announcing a greeting. There is only the shape of the signal, its timing, its place in the sky. And yet, for the people who stare at it, the emotional weight is heavy. The heart moves faster. The mind drifts to possibilities it has held in secret for years. What does it mean to imagine a reply? For so long, Earth has been the talker, sending out our lonely signals, our fragile hearts wrapped in radio waves. Our telescopes listened, but they listened with the expectation of silence. A reply, even a hint of one, changes the story. It turns the universe from a vast, empty hall into a room where someone might be standing just out of sight. If another civilization hears us, what picture do they form? Our TV shows, our wars, our music, our weather reports, our scientific broadcasts describing the orbit of the Earth, the chemistry of water, the structure of DNA. They might see a species, still young, still confused, but trying to understand itself and the cosmos at the same time. In the control room, people speak in careful voices. They talk about signal-to-noise ratios, Doppler shifts, and telescope alignment. But underneath their words, another conversation runs silently. What if this is it? What if we are seeing the first tiny thread connecting us to a mind beyond Earth? Some are excited. Some are afraid. Some feel a quiet sadness, as if realizing that humanity, for all its noise, is very small in a universe full of ancient travelers and drifting shadows. A reply would mean we are not alone, but it would also mean that our story is not the only story. We would share the stage with something older, wiser, or simply different in ways we cannot yet imagine. Religions, philosophies, and dreams would bend under that weight. Some people would feel their faith deepen, seeing a larger design in the fabric of space. Others would feel their beliefs tremble, forced to expand beyond Earth's shore. Economies, politics, and culture would shift, slowly at first, then faster, as the idea of us stretched to include them, even without a clear message. The hint of a pattern near Jupiter already touches these thoughts. The planet becomes more than a giant ball of storms and bands. Its moons Europa, Ganymede, Callisto, and the rest feel like possible stages where something could unfold. Under ice, in thin atmospheres, or in orbits shaped by hidden hands. The mind imagines invisible cities or silent instruments waiting in the cold. Yet most of the time, the control room is calm. Someone checks the clock. Someone writes a note in the log. The telescopes continue their slow sweep of the sky, tracking exoplanets as they dim their stars, watching nebula clouds that glow softly in infrared light. Life on Earth goes on. People sleep, dream, wake, and go to work, never knowing that a thin line of data near Jupiter has brushed against the edges of human destiny. SETI is, in many ways, an act of faith without religion. It is the belief that the laws of physics and chemistry, which shape every orbit and every comet trajectory, could also shape minds elsewhere. That somewhere, under another starlight, someone has built their own telescopes, tuned their own receivers, and asked their own version of the question we ask tonight. If they are out there, they might be listening now, their instruments pointed toward our pale blue dot, catching the faint fuzzy blur of our broadcasts. To them, our signals might seem just as haunting and incomplete as their possible reply feels to us. A faraway pattern, a hint, a messenger without clear words. So the work continues. Day after day, night after night, people return to these quiet rooms. They refine their algorithms, trying to separate true anomalies from random noise. They compare notes with teams across the world, linking telescopes into networks that span continents, turning Earth itself into a kind of giant listening ear. The strange signal near Jupiter stays in their thoughts. It sits on whiteboards and in shared folders, marked with cautious labels: candidate, unconfirmed, follow-up needed. The scientists know that without proof, they must remain careful. One wrong claim could damage the field for years. So they hold their excitement close, like a secret flame cupped in two hands. And yet, late at night, when the control room grows still and the glow of monitors softens, those same people sometimes allow themselves to drift. They imagine a future where the pattern is fully understood, where the signal is no longer just a spike in a graph, but a doorway into a new chapter of human experience. Maybe, in that future, children will grow up knowing that the universe is not silent. That somewhere beyond Jupiter, beyond the nearest nebula and the nearest exoplanet, another sky is listening back. Maybe they will look up, wrapped in blankets under a dark field, and feel not fear, but a deep, steady comfort, the sense of belonging to a cosmos that is awake. For now, though, the night remains mostly quiet. The telescopes keep turning. The data keeps streaming. The lonely signals leave our planet and fade into the dark, carrying pieces of our laughter, our sorrow, our fragile hope. In return, we listen patiently, carefully for anything that might answer. The strange echo near Jupiter lingers at the edge of understanding, like a dream half remembered when you open your eyes. The silence deepens around it, and yet, hidden in that silence, there is the feeling that something more is waiting to be seen, a pattern just beyond reach, holding a secret it has not quite decided to reveal. The chapter opens in a dark, quiet control room, lit only by the soft glow of screens. On the main display, Jupiter hangs in space like a giant lantern, its bands of cloud and storm wrapped around a deep swirling heart. Tiny points mark its moons, bright specks following precise orbits. It is a peaceful view, slow and steady, a moving painting above rows of humming machines. Below that image, the sky looks very different. Numbers slide down the monitors. Graphs rise and fall in thin, flickering lines. Speakers murmur with a faint, steady hiss. This is how astronomers listen to the universe, not with their ears, but with instruments tuned to radio waves and hidden light. Most of what they receive is simple noise, the constant static of a restless cosmos. The universe is full of this static. Old stars crackle. Galaxies hum. The faded glow of the Big Bang spreads across the sky as a thin mist of background noise. If you have ever turned a radio between stations and heard the soft rush in the gaps, you have brushed against that cosmic whisper. It is random and uneven, like raindrops on a roof in a distant storm. On screen, that randomness becomes a cloudy blur of points. Jupiter's radio storms carve sharp spikes. Charged particles in its magnetic field scribble messy shapes. Distant objects flicker in and out. Over years, scientists have learned to read these traces. A comet has one kind of curve, an asteroid another, a storm still another. The sky turns into a catalog of familiar fingerprints and scribbles. That is why the new signal near Jupiter feels so unsettling. At first, it is almost nothing. A small bump in a long stretch of static. One night, a research assistant notices a neat little rise and fall on a graph and marks it with a short note. Anomaly. Check later. Most odd blips turn out to be harmless instrument. Glitches passing cosmic rays or one-time bursts that never return. Space is generous with small surprises that mean very little. But this one returns. Weeks later, during another observation of the Jovian system, a second bump appears. It rises and falls in nearly the same way, in almost the same region of space. When both events are laid over each other, their shapes seem to rhyme. Not identical, but close enough to stir that quiet feeling that something is repeating where it should not. The team begins to search for simple answers. They check catalogs of comets and asteroids, looking for any object that might have crossed the path of the telescope. They scan records of solar flares and known radio storms. They rule out signals from spacecraft and satellites. They trace the orbits of Jupiter's moons, following every path that might twist or reflect a signal. Possibility after possibility falls away. The signal is too smooth to be a random glitch, too irregular to match a steady machine. It sits in an uneasy space between tidy and chaotic, like a voice almost hidden in the wind. In private notes and late conversations, someone gives it a quiet name. The forbidden pattern, a shape that refuses to fit into the usual boxes. To understand why this matters, it helps to think about chance. Imagine rolling a die again and again. Most of the time, the results look random. But every so often you might see a tidy run 1, 2, 3 in order, or several 6s in a row. It feels special, but it is still allowed by chance. In a big enough sea of random outcomes, small patterns appear on their own. The universe behaves in the same way. In the vast noise of radio waves, some patches will line up in neat designs. Astronomers know this well. They remind themselves that coincidence is powerful and the cosmos is enormous. For every curious pattern that catches a human eye, many more drift past unseen. It is easy, almost dangerously easy, to connect dots that do not truly belong together. And yet, the pattern near Jupiter keeps returning. Over months of listening, the signal shows up again and again, always within a certain window of time and position around the giant planet. It does not repeat with the exact timing of a beacon. Sometimes it is faint, sometimes clearer, with long quiet stretches in between. But when the events are stacked together, the curves of their rises and falls echo one another in a way that is hard to ignore. Slowly, another idea takes shape. Perhaps the pattern does not come from a single, hidden source, but from a moving dance of many things at once. Jupiter is not alone. Its strong magnetic field wraps around a crowd of moons that sweep through invisible lines of force. As those moons travel along their orbits, they pass through regions filled with radio storms and streams of charged particles. The researchers begin to picture the moons not just as frozen stones of rock and ice, but as shifting lenses and shutters. Jupiter's storms send out rough, roaring noise. As the moons cross that roar, they could block some parts, focus others, or chop the signal into pieces. Seen from far away, the result might look like a series of pulses and pauses, a pattern that feels deliberate, even if it is only the work of gravity and motion. Then an even softer thought appears. What if, in a way, the moons are acting as a messenger? Not a built device, but a system that reshapes noise into something that looks structured. If a broad radio broadcast from Earth passed through this busy region, could the moving moons carve it into a more complex shape, turning an ordinary signal into peaks and gaps that seem to answer back? As if the Jovian system were quietly reshaping our own voice? No one can yet say. The math is difficult. The computer models are slow. Each new attempt raises more questions. How likely is such a pattern? How stable would it be? How often would orbits line up just the right way? There are easier explanations that still wait in the background, strange twists in the magnetic field. Rare natural storms, subtle flaws in the instruments that only show up under special conditions. So, in official papers and meetings, the tone stays cautious. The anomaly is noted. The pattern is described with gentle language, unexplained, understudy, not yet fully understood. The forbidden pattern is kept at a respectful distance, an open question rather than a bold claim. Yet in the quiet hours of the night shift, when the room is dim and the graphs glide slowly by, the mind wanders farther than reports allow. If you were sitting there, watching those thin lines with tired eyes, you might feel it too. You would nod at the warnings about chance and statistics. And still, a small part of you might wonder if the universe is trying to speak with timing and orbit, using moons as moving mirrors. The pattern near Jupiter does not shout. It lives on the edge of what the instruments can see, in small rises above the constant hiss of the sky. It appears and disappears like a drifting shadow, leaving only faint echoes in memories and logbooks. You cannot prove it means anything at all. You cannot quite believe it means nothing. Far beyond the walls of the control room, Jupiter continues along its wide path around the sun. Its clouds swirl in soft bands of cream and rust. Its storms spin and fade and return. Its moons slip through the dark in their careful trajectories, gliding through a cradle of silence that has lasted for billions of years. The planet does not know it is being watched. But for a handful of observers, Jupiter now carries an extra layer of wonder. It is not only a giant world wrapped in storms. It is also a place in the sky where noise seems, at times, to lean toward order, where a forbidden pattern appears, just often enough to keep hope and doubt balanced on the same thin line. And so they keep listening. They adjust their telescopes, refine their software, and return their attention to the Jovian system again and again. Each new observation is another small thread added to a fragile web of clues that might one day make sense or quietly dissolve back into chance. For now, the pattern remains a gentle tension in the data, a soft question pressed into the fabric of the night. As the hours grow late and the last screens dim, the hiss of the universe continues, calm and endless. Somewhere inside that ocean of static, near a giant planet and its circling moons, a faint rhythm seems to persist, like a distant heartbeat at the edge of sleep, hinting that something hidden may still be waiting in the noise, patient and unexplained. Out beyond Mars and the faint dust of the asteroid belt, Jupiter turns slowly in the dark. Around it hangs a soft halo, a luminous haze made of thin gas and charged particles, trapped and guided by a huge magnetic field. From far away, it would look like a gentle veil. To the instruments that listen carefully, it is a busy place, full of small, quiet signals. Among those signals, 3 stand out. There are sudden bursts of particles near Io's orbit. There are subtle shifts in the magnetic field around Ganymede. And there are faint echoes that seem to appear when Europa moves through certain streams of plasma. Each on its own is easy to ignore. Just another odd line on the graph. Together, they feel like harbingers not of disaster, but of deeper knowledge waiting in Jupiter's glow. Io, the most volcanic world in the solar system, orbits close to Jupiter, squeezed and heated by gravity. Its volcanoes throw sulfur and oxygen high into space. There, the atoms lose electrons and become ions, joining a thick ring of charged particles called the Io plasma torus. This torus wraps around Jupiter like a glowing necklace, bright in ultraviolet starlight. Spacecraft that cross the torus carry particle detectors and wave sensors. Most of the time, their data match the models. The plasma flows steadily, racing along magnetic field lines that curve around the planet. On a screen, the graphs look smooth, like a calm but fast river. But every so often, near Io's orbit, sharp bursts of high-energy particles rise and fall in minutes. On the graph, they show as thin spikes. Cameras do not see a matching eruption on Io. The sun, watched from afar, is quiet. The bursts come and go as if from nowhere. The first doubt always points inward, toward the machine. Engineers check the spacecraft's power levels, its orientation, the health of each detector. They compare one instrument with another. If only one sensor shows the spike, the team stays cautious. When several instruments see the same brief burst, the signal becomes harder to dismiss. What is left after these checks is simple and puzzling. Short particle bursts linked again and again to Io's orbit, rising inside the luminous haze like tiny sparks from an unseen engine. They may mark strong electric currents flowing along magnetic field lines between Jupiter and Io. They may trace miniature magnetic storms, too small to light up the sky. For now, they remain as questions written in numbers. Farther out orbits Ganymede, larger than the planet Mercury and wrapped in its own magnetic field. Deep inside, a molten core drives that field, forming a small magnetosphere inside Jupiter's much greater one. It is like a bubble of magnetism floating in a wider magnetic sea. When spacecraft pass Ganymede, their magnetometers feel how the field bends and twists. Most crossings look the same. a smooth dip and rise as the probe passes through the moon's magnetic bubble. Models predict this shape well. Yet on a few passes, the curve changes. The dip is not as deep. The rise arrives slightly late. The smooth line becomes a little crooked, as if someone has tugged softly on the field. Again, the instruments are checked. Engineers look for small rotations of the spacecraft, for thruster firings, for anything that could disturb the reading. Scientists compare with space weather reports to see whether the solar wind squeezed Jupiter's magnetosphere at the same time. Much of the time, these checks explain the data. But some traces remain stubborn. They do not fit known solar events or spacecraft motions. They hint at activity inside Ganymede's own field, perhaps slow changes in the molten core, perhaps brief events where magnetic lines snap and rejoin, releasing energy in quiet, unseen bursts. If so, these subtle distortions are gentle clues that the moon's interior is still moving and alive with heat. The third puzzle belongs to Europa, a bright moon covered in cracked ice. Beneath its frozen shell, strong evidence points to a deep, salty ocean. As Europa travels through Jupiter's magnetic field, the changing field induces electric currents in that ocean. Those currents create faint secondary fields, like a shadow of Jupiter's magnetism. Plasma instruments near Europa sometimes pick up delicate changes tied to the moon's motion. When Europa enters certain plasma streams, the waves in the charged gas shift slightly. Very faint radio signals rise and fall in a pattern that repeats with its orbit. Once more, the data are cleaned and compared with solar activity. Once more, some traces remain. Those traces seem to carry clues about the hidden ocean, how deep it might be, how salty, how the ice crust above it might be layered. The signals are not strong enough to give clear answers, but they are steady enough to say, there is more here than ice and rock. None of these three puzzles is loud. The bursts near Io, the bends at Ganymede, the echoes at Europa could all be called noise. Space around Jupiter is naturally complex. Particles, fields, and waves are always interacting. A perfect, simple pattern would be more surprising than a messy one. Yet, when scientists place these signals side by side, a larger picture appears. Jupiter's system is not just a set of moons circling a planet. It is a connected environment. What happens near one moon can send ripples through the luminous haze that reach another. The magnetosphere acts like a vast, invisible ocean. Moons, plasma, and fields are all passengers and shapers of its tides. From Jupiter's cloud tops, storms swirl and fade in colorful bands. Above them, unseen, charged particles spiral along magnetic trajectories, drifting in loops that can stretch for hundreds of thousands of miles. Waves move through the plasma, carrying energy from place to place. The soft halo around the planet is not just a glow. It is the visible trace of this constant motion. From Earth, we catch only hints. Telescopes see the bright flash of auroras near the poles and the dim ultraviolet ring of the Io Taurus. Radio antennas pick up bursts when Jupiter points its beams toward us. The fine details remain hidden until a spacecraft flies through the haze, turning invisible forces into lines on a screen. To most people, those lines are just data. To the teams who study them, they are quiet messages. They do not say, life is here, or an ocean lies exactly this deep. Instead, they say, something is changing. Look closer. Keep listening. Because of these hints, future plans are drawn with more care. New telescopes in orbit and on the ground are being designed to watch Jupiter's auroras in finer detail, noting how they flicker when Io, Europa, and Ganymede cross special regions of the magnetosphere. Better spectrographs will split the light into very fine colors, revealing which ions glow in which parts of the haze. Future spacecraft will carry more sensitive magnetometers and plasma detectors. They will orbit the moons for longer and repeat the same paths many times. A mission around Io could follow volcanic activity and see how fast the surrounding plasma responds. One at Ganymede could map its magnetic bubble more closely, checking whether those strange bends appear again. An orbiter at Europa could fly repeatedly through key plasma streams, listening for the same gentle echoes from the hidden ocean. All of these tools share a simple goal: to listen more closely to Jupiter's luminous haze and to the small harbingers hidden within it. With enough careful listening, the hope is that these whispers will form patterns, and the patterns will grow into understanding. If you imagine yourself aboard one of these probes, the scene outside is calm. Jupiter looms like a striped lantern in the dark. The moons move like slow beads along invisible threads. The haze itself is only a faint glow. Inside the spacecraft, instruments hum softly, counting particles, feeling tiny changes in magnetic pull, catching radio waves far too weak for human ears. For now, they live in stored data and careful notes, in quiet graphs and long reports, in the minds of people who keep returning to them. They are not warnings to make us afraid, but invitations to keep wondering. And so the luminous haze around Jupiter continues to glow, wrapped gently around the planet and its moons. Within it, unseen currents twist and mingle, and delicate signals rise and fall like a slow, distant breath. The silence out there feels deep and soft, and within that silence, something still hidden waits to be understood. On a high, dry plain, far from any city, a field of radio dishes rests under the stars. Their pale curves tilt toward the sky, not to see, but to listen. In the cool air, they stand like quiet shells, catching waves that have crossed the whole solar system. They hear the sun's crackle, the hiss of distant nebulae, and the soft background of the Big Bang. Folded into that noise is the faint radio glow around Jupiter and its icy moons. These are the listening towers of today. The towers of tomorrow exist, for now, as plans on screens. Engineers imagine arrays spread across deserts, thousands of antennas linked together as one vast ear. Others picture instruments on the far side of the moon, shielded from Earth's restless signals by a wall of rock. In that lunar cradle of silence, our own chatter would fall away, and even the smallest whisper from Jupiter's realm could rise out of the dark. On Earth, giant optical telescopes are also taking shape. Their mirrors will span tens of meters, polished so smooth a grain of dust would seem huge. Sitting on mountaintops above the clouds, they will open their domes at night like slow eyelids. Paired with advanced spectrographs, they will slice starlight into thousands of colors. By watching how that light changes as it passes near Jupiter and its moons, scientists will search for tiny dips, flashes, or strange patterns. In deep space, new orbiters and probes are being planned to revisit the Jovian system with sharper senses. Some will carry ice-penetrating radar, sending pulses into frozen crusts and listening for echoes that mark layers of liquid water or buried structure. Others will bring cameras that see in infrared and ultraviolet, revealing heat and chemistry hidden from human eyes. Electric and magnetic field sensors will trace invisible lines that link Jupiter to its moons, following currents that may carry more than simple charge. Each instrument will add one more way to listen, one more angle on the same old mystery. Mission planners trace careful curves on digital maps. A spacecraft may loop past Earth, then Venus, then Earth again, stealing speed before turning outward. Years later, it will fall into Jupiter's gravity well and fire its engines to slow down. From there, it can slip into orbit around the giant planet or drop lower to circle Europa, Ganymede, or Callisto. Each mission is a quiet dance, timed so its instruments arrive in the right place at the right moment to catch a plume, a shadow, or a burst of radio noise that lasts only seconds. Close to the moons, orbiters will fly low over cracked ice and dark plains, mapping texture and temperature with patient care. If plumes rise from subsurface oceans, the craft will skim through them, tasting the vapor for salts, organic molecules, and unusual energy signatures. Each pass will add another line of data, another stitch in a growing map. Worlds that once looked like tiny dots beside a bright planet will become detailed landscapes traced line by line. With every orbit, the picture of what these moons are and what they might hold will sharpen. Someday, landers and maybe small rovers may follow. Imagine a compact machine settling on Europa's frozen surface, its landing legs sinking slightly into brittle ice. Above it hangs Jupiter, a vast striped lantern in a black sky. Around the lander, the world is almost silent. The only sounds are faint creaks from shifting ice and the soft clicks of its tools. It drills, warms a sample, and lets spectrometers sniff the vapor for complex carbon chains and unusual ratios of elements. A small antenna lifts and sends the findings upward to an orbiter, and from there across millions of miles to Earth's waiting dishes. To read this flow of information, new tools are being built from code. Machine learning systems and AI will sift through images, radio recordings, and spectral lines that human eyes could never finish. Where a person sees static, an AI can find structure. It can notice when a narrow frequency flickers in rhythm with a moon's orbit, or when a faint repeating shape appears in Jupiter's tangled magnetic field. At first, it will be tested on known signals, pulsars, spacecraft beacons, lightning in the giant planet's clouds until it learns the normal music of the sky. Over time, these systems will be trusted with more. An AI may flag an anomaly that returns every few days, matching Europa's path, or a quiet beat hidden in a set of spectra, a rise and fall that seems too regular to be chance. Each alert will not be proof, but it will be a place to look again more closely. Scientists will pair the AI's pattern finding with human judgment, asking the simple question that has followed every strange signal so far. Is this nature or something else? While the tools grow more sensitive, our own broadcast will keep changing. Old, broad radio signals are being replaced by narrow beams, tightly aimed to save power. Space agencies and private companies plan powerful transmitters on satellites and, perhaps one day, on the moon, beaming data and energy across the solar system. Messages to distant probes, future crews, and far-off bases will ride on these beams like cargo on invisible rails. They will sweep past Jupiter and its moons, wash over ice and rock, and continue outward, crossing the shadows of black holes, the thin clouds of supernova remnants, and the spaces between distant galaxy clusters. If anything in the Jovian system is listening or shaping a reply, it will have more and more to work with. Our signals will tell a story, even without words. Bursts of activity when new missions launch, long quiet stretches when attention shifts elsewhere. Sudden spikes when something breaks and teams on Earth race to respond, all of this will be written into radio and light. To a distant watcher, human or not, Earth's moods might look like changing weather across the face of a thinking world. The search will not be simple. Space has its own wild music. Black holes feed and roar. Pulsars flash with clockwork beats. Magnetars crackle. Jupiter itself throws out radio storms bright enough to be heard on Earth. In that crowded chorus, any artificial pattern would be faint, like a single voice far away. There will be many false leads. Stray pulses from satellites, glitches in receivers, new natural rhythms we did not expect. Each time, scientists will retrace their steps, compare with other observatories, and check again. Yet through all of this, a quiet hope will remain. In labs and control rooms, lit by soft screens, people will sometimes pause and imagine what it would mean if one of those strange patterns stayed strange, no matter how closely it was tested. They will picture an ocean under ice, stirred not only by tides and heat, but by choice. They will imagine a signal shaped on purpose, woven into the storms and fields of Jupiter's vast domain, waiting until our tools grew gentle and sharp enough to notice. And so the listening towers of the future rise in steel and silicon, in powdered lunar dust and frozen plains of distant moons, and lines of code that do not sleep. Each dish, mirror, and sensor is a small promise that we will keep watching and keep listening, sending our fragile broadcasts into the dark. Around Jupiter, the night will still seem empty to our eyes. But within that quiet, there will be space for the smallest brushstroke of a reply, soft as a breath, patient as a dream that has not yet been fully remembered. The Jovian system hangs in space like a slow, turning clock. Jupiter glows with its banded clouds, and around it drift its many moons, each one locked in a silent orbit. From far away, they look so quiet, like frozen beads of light. But tonight, in this soft, drifting moment, a question rises. If the moons could reply, what would they say back? All across Earth, antennas have already been listening. For decades, radio dishes turned their wide, metal faces toward Jupiter. Spacecraft flew past, pointed cameras and spectrographs at Europa, Ganymede, and Callisto. Data streamed home like snow on a screen. Scientists studied numbers, charts, tiny changes in starlight and radio noise. They looked for order in what seemed like chaos. Even without life, the moons already speak. They reply in their own natural language: light, plasma, and motion. When charged particles race through Jupiter's huge magnetic field, they strike the moons and send out radio bursts. When sunlight hits ice, it scatters in a specific way. When Europa passes through Jupiter's shadow, its thin atmosphere and frozen surface cool and warm with a slow, gentle rhythm. All of this is a kind of answer, even if it is not meant for us. Imagine this reply as a very old song. The orbit of each moon is a beat. The tilt of its axis is a note. The ice crust, the hidden ocean, the rock below, all of it forms an instrument. Jupiter's magnetic field is the bow drawn across the strings. The result is a web of signals, radio waves, bits of plasma, soft glows of aurora near the poles. Our telescopes and probes are simply microphones held up in the dark, trying to catch the tune. Now the picture shifts. You are no longer on Earth, looking through a screen. You float above Europa in a small, quiet ship. Outside the window, the moon's surface stretches away in ridges and cracks, a pale maze of ice lit by Jupiter's reflected glow. There is no sound in the vacuum, yet your ship's instruments hum softly in the background, always listening. Down below, under miles of ice, an ocean moves. This is not just ice and rock. Tides from Jupiter's poles stir the water. Heat from the moon's core rises along the seafloor. In that dark sea, vents may billow warm, mineral-rich water like underwater chimneys. On Earth, similar vents became homes for simple life long ago. Microbes gathered there, drawing energy from chemicals instead of sunlight. If Europa follows the same pattern, its ocean may be full of tiny blind swimmers and clingers, drifting and feeding in the black. If such microbes exist, they do not know we are here. They have no language, no telescopes, no maps of the stars. Yet they change their world. They eat and release gases. They build thin films on rocks. They clump together and break apart. Over time, these actions could slightly change the chemistry of the ocean. They could alter how electricity flows through the water. That change, spread across an entire ocean, might affect Europa's electromagnetic fields in small ways. To them, it is nothing, just daily life. To us, tightly focused and measuring from orbit, those changes might look like a faint, repeating pattern, a tiny deviation from what we expect. It would not be a sentence. It would not be a word. But it would be a reply all the same. We are here. Something is happening under this ice. Perhaps, as your ship circles above, the instruments pick up a soft, steady pulse in the radio data. It rises and falls not with Jupiter's rotation, but with cycles in the ocean below. Maybe it repeats every few days or every Europa year. Maybe it matches the model of tides crossing some rough, uneven seafloor. Or maybe it matches something else, something we did not predict. Now, let the mind drift even further, gently, carefully. What if, somewhere in that ocean, life is not only microbial? What if time and chemistry have given rise to something more complex? Not cities, not machines, not anything like our own civilization, but perhaps wide mats of linked organisms that pass signals from one to another. Or slow, drifting colonies that sense heat, pressure, and chemical change, then respond together. Over millions of years, such networks might grow more sensitive. They could begin to notice the regular pull of Jupiter, the faint warmth from the rocky bottom, even the rare crack of ice from above when the crust shifts. They might not think in our sense of the word, but they might form patterns inside themselves, like simple thoughts. Now imagine those patterns reaching outward. When energy flows through their bodies, it changes the saltiness or temperature of the water around them. That in turn shifts how electric currents pass through certain regions of the ocean. Those shifts rise up through the ice as tiny changes in magnetic fields. From our ship, high in orbit, the instruments read those changes. To our computers, they are lines on a graph, tiny, spiky peaks in a long, quiet curve. To us, listening in the soft light of the cabin, they look almost like a heartbeat. It is important to be gentle here. Science demands care. It asks, could this instead be caused by the shape of the core, or a shift in the ice shell, or a quirk in Jupiter's plasma? Many questions come before any claim. No documentary, no late-night show, no excited headline can skip that slow work. But still, the idea stays. If a pattern remains after all other causes are tested, then the moons may be replying in the only way they can. Not in words, not in music, but in the long, patient language of physics and chemistry. Notice how the tone of this thought is not fearful. There is no invasion here, no attack, no angry cosmic judge. If anything lives beneath Europa's ice, it is fragile. It fights against cold and darkness every moment. It has survived eons without harming anyone. Its message, if we can call it that, might be nothing more than the fact of its survival. A soft glow of life in a place that seems impossible. From the window of your ship, Jupiter fills half the sky. The bands of clouds slide past, and a storm older than all of human history turns slowly like a red eye. The other moons drift by, each on its own track. Somewhere on one of them, a spacecraft orbits with you, measuring, waiting. Inside, human eyes follow the graphs on a dim screen. Outside, the cosmos is calm, and the cradle of silence seems endless. On Earth, the reply would echo in a very different way. If evidence of life, even simple life, were confirmed beneath Europa's ice, our own world would feel changed overnight. Streets would look the same. Oceans would rise and fall with the moon as they always have. But inside, people might feel a shift. Some would feel less alone. The thought that life does not belong only to Earth, that it can bloom even in darkness and ice, would bring comfort. We would know that the universe does not waste chances. If it happened here and there, maybe it happens everywhere on distant exoplanets, on worlds that circle red dwarfs, in oceans under other icy shells. Others might feel that our destiny has grown larger. If there is a second ocean of life in our own solar system, then our future could include careful visits, gentle exploration, and responsibility. We would become not just observers, but neighbors. The idea of home would stretch to include other moons and planets, other fragile ecosystems swimming in the dark. You, listening in the quiet of your room, might feel both things at once. Less lonely, yet more aware of how much there is still to learn. Sleep might come with images of floating over Europa's cracked surface, watching faint auroras flicker along the horizon. In your mind, you might hear a low, distant hum, as if the moon itself were singing. In truth, the song would be numbers and waves, peaks and valleys in data. But when those numbers are translated into sound or color or moving lines on a screen, the effect is the same. It feels like a whisper across space. A reminder that for all our searchlights and radio calls, the universe has been speaking in its own way all along. And so we return to the simple question that started this gentle journey. If the moons could reply, what would they say? Perhaps the answer is not a clear sentence, but a feeling. A faint echo of Earth's own songs, reflected and reshaped by ice, ocean, and plasma. A quiet yes to the possibility of life. A soft hint that we are part of something wider, older, and more mysterious than any one world can hold. Above Jupiter, the moons continue their slow dance. The glow from the giant planet paints their ice in shades of silver and blue. Instruments in the dark keep listening, and the data keeps falling like slow rain into human hands. For now, the greatest part of their message remains hidden. Yet as the orbits turn and the silence deepens, there's a sense subtle and dreamlike that within that silence, something is waiting to be understood. Beyond Jupiter's pale storms and glowing moons, the story stretches outward. It leaves the busy inner solar system and drifts into a wider, quieter dark. Out here, there is no air, no sound, only thin threads of radiation sliding past one another. Among them is something small and fragile, a sphere of radio waves made by a single, young species on a blue planet near a modest star. Seen from far above Earth, that sphere begins as a faint halo. The planet turns below, white clouds sliding over blue oceans and brown lands. Radio towers and satellites send out messages, songs, warnings, and data. Radar scans the skies. Deep space antennas talk with distant probes. Most of this energy bends back down or fades in the atmosphere, but a tiny part escapes. Those escaping waves become travelers, carrying scraps of human memory into space at the speed of light. With every year that passes, the halo swells, reaching and passing the orbit of Mars, where rovers whisper their own narrow beams home beneath a thin pink sky. Then stretching across the asteroid belt toward the giant planets. Jupiter, with its torn clouds and family of moons, slips behind you like a finished chapter. Ahead lies Saturn, wrapped in broad rings that shine in faint sunlight. Spacecraft that once passed this world turned their dishes outward as they flew, listening to the hiss of charged particles and the deep murmur of magnetic fields. For a short time, those probes were metal islands in a vast, silent sea, catching whispers from the cosmos and sending their findings home as thin threads of radio. Even those brave machines are close by compared with the halo. The human-made bubble continues outward, past Uranus and Neptune, beyond the cold orbits of dwarf planets and comets. Far past Pluto's path, the sun shrinks to a bright star among many. The halo keeps growing, thinning and fading, but still real, a fragile shell of signals spreading into an ancient, natural hum. From this, a question rises, soft but persistent. Do our broadcasts already brush past unknown travelers? Do they skim over alien oceans and continents or slide across the hulls of ships that never knew Earth existed? To look for any reply, Earth turns great ears toward the sky. In wide deserts and mountain basins, enormous radio telescopes face upward. Some are single dishes as wide as a sports stadium. Others are long fields of small antennas, simple by themselves, powerful together. They sweep the heavens in careful patterns, gathering radio waves that have traveled for thousands of years. Their target is not random noise, but order and narrow tone. A repeating pulse, a signal that looks more designed than accidental. Many of these searches focus on exoplanets, the countless worlds that circle other stars. some orbiting at the right distance for liquid water. Radio telescopes turn toward these promising systems and listen near quiet parts of the spectrum, including the band where hydrogen naturally emits. This region is like a low-traffic lane in the cosmic highway, a place where a deliberate signal would stand out. A narrow, bright line there, repeating with careful timing, could be the leak of another civilization's own radio glow, or a beacon built on purpose to say, across light years, we are here. Other searches look toward harsher places, pulsars and regions shaped by ancient supernova explosions. Pulsars are dense spinning remnants of giant stars, sending beams of radio waves sweeping through space like lighthouses, turning with clock-like regularity. Nearby, and in the wreckage left by supernova, shock waves curl and collide. Magnetic fields twist into knots, and fast-moving particles give off a soft hiss of radio noise. By studying these signals, astronomers learn how galaxies change and how heavy elements spread, while also watching for anything that does not fit: a thin tone, a repeated pattern, a small anomaly hiding in the roar. In all these searches, listening is slow work. Receivers collect streams of data that flow into computers day and night. Algorithms pick through the patterns, looking for spikes and lines that stand out. Most odd signals turn out to be our own: aircraft radar, satellites, ground-based transmitters, even microwave ovens near observatories. The space around Earth is crowded with our technology, and real whispers from the universe must be found inside our own noise. As you drift with these thoughts, your view pulls farther back still. The solar system shrinks to a bright pin for the sun and dim sparks for the planets. Around that tiny model, Earth's radio halo looks like a thin shell, delicate as breath. Against the age of the galaxy, it is very young. Against the size of the Milky Way, it is almost nothing at all. Inside that almost nothing, however, a record of our species is stored. Early TV shows, first satellite test signals, news reports, songs, and fragments of conversation all glow faintly inside the bubble. None of it was meant for alien ears, but all of it is on its way toward the stars. Jupiter's moons fit into this larger picture like a single bright thread. Europa with its hidden ocean, Ganymede with its magnetic field, battered Callisto, fiery Io, they belong to the same family of questions as distant exoplanets. Pulsar systems and regions shaped by ancient supernova. Wherever there is energy, structure, and time, the same hope appears, that life might have found a foothold, looked up, and wondered if someone was out there. The tools we use change: eyes penetrating radar here, radio telescopes there, but the feeling that drives them is the same quiet curiosity. On the night side of Earth, city lights flicker on. Radio towers blink in red and white. Deep space antennas send commands to probes beyond Neptune and wait for faint replies. The planet's radio glow brightens a little, like a soft lantern in a vast hall. To the galaxy, it is tiny and fragile. To the people who built it, it is proof that they have learned to reach beyond their cradle of silence. Scientists often say that if we ever confirm a true reply, if a narrow beam from another world cuts through the noise and repeats with clear meaning, everything will change. It would not just be a new fact in a database. It would be a mirror held up to our story. We would know that thinking minds have bloomed at least twice in the universe. Every map, every belief, every quiet thought about our place among the stars would feel different. For now, that moment lives only in imagination. No confirmed message has arrived. No clear voice from another world has stepped out of the static. What we have instead is the act of listening and the steady, unnoticed leak of our own broadcasts into the dark. Together, they form the beginning of a conversation that, so far, has only one speaker. As you drift towards sleep, imagine yourself resting on the surface of that expanding halo, carried outward with every old broadcast and every new whisper. Around you, stars shine like faint islands in an endless sea. Some may host oceans and clouds under strange colors of light. Some may be wrapped in halos of their own, radio bubbles spreading into the dark. The answers to whether we are alone, whether anyone hears us, whether a reply will ever touch our world, are still hidden in the spaces between those distant suns. But the signals keep traveling. The telescopes keep turning. And in the wide, silent dark, there is room for wonder and for the feeling that beyond the edge of what we can hear, another whisper may already be moving toward us. Written in the starlight dot, the night sky has always felt like a page waiting to be read. Long before there were telescopes or spectrographs, people tilted their faces upward and tried to make sense of the glittering dark. They did not know about orbits, exoplanets, or galaxies, but they knew the steady rhythm of the seasons, the slow drift of familiar stars, and the sudden shock of something new. A strange light, a moving spark, a long-tailed visitor cutting across the sky. To them, each of these was a message. In ancient cities and quiet villages, under that same soft glow, comets were feared as harbingers. A pale flame would appear above the horizon, stretching a silver tail like a ghostly banner. Priests and leaders would gather, their voices low. Was this a warning? A sign of war or famine or change? Stories grew around each shriek of light, wrapping fear and wonder together. If the cosmos could send a warning, perhaps it could also send a blessing. Some people looked up and whispered wishes into the darkness, trusting that the sky was listening. They traced the slow crawl of planets, the rising of constellations, and the brief, bright flash of meteors, as if the universe were writing in a secret code only the patient could read. Centuries passed. Empires rose and fell. The same stars remained. Slowly, humans learned that comets were not angry spirits or omens of doom, but ancient travelers of ice and rock, following long, graceful paths around the sun. Their bright tails were not curses, but sunlight warming dust and frozen gases. The fear around them began to fade, replaced by curiosity. The harbinger became a guest. Telescopes grew larger. Cameras grew sharper. Computers began to help. The night sky turned from a source of dread into an open field of questions. Now, when astronomers look up, they still search for messages. But the messages have changed. They listen for faint radio waves whispered through the dark, hoping for a clear signal that does not come from stars or galaxies, but from somewhere stranger. A pattern that repeats. A rhythm that cannot be explained by chance. A sign that, somewhere out there, another mind is also looking into the sky and wondering if it is alone. In quiet observatories, dishes turn like slow, metal flowers, their curved faces pointed at the stars. Computers sift through data, hunting for anomalies in the noise. To most people, the numbers on the screen look meaningless. But to the patient watcher, each tiny spike, each gentle rise and fall, feels like a heartbeat in the void. So far, nothing certain has appeared. No clear voice. No final proof. But the search itself has become its own kind of story. People imagine what that first message might be. A simple pulse repeating in a steady beat, like a lighthouse in the cosmic sea. A series of prime numbers. A map, a greeting, an echo of our own transmissions, bounced back by something that heard us and chose to reply. And even if no such signal comes, the dream remains soft and comforting, like a tale told at the edge of sleep. It reminds us that our questions are not empty. They are part of how we make peace with the vastness around us. Prophecy, once tied to fear, is now also tied to imagination. The universe is not a storyteller in the old sense. It does not choose heroes or villains. It does not promise happy endings. Yet, when people look up at the stars, they cannot help but weave their own meanings into the glow. They see the arc of a comet and think of change. They see a bright planet and think of journeys. They see a nebula lit by newborn stars and think of beginnings. Science does not erase these feelings. It gives them a new shape. When a spacecraft swings past Jupiter and sends back pictures, the images are not just data. They are pages in a living book. Jupiter's bands swirl like a painted storm, and around it, its moons shine like beads on a dark string. Io, fiery and scarred. Europa, smooth and bright, hiding a deep ocean beneath its frozen crust. Ganymede and Callisto, old and cratered, turning slowly in their orbits. Once, distant lights like these might have been seen as wandering gods or watchful eyes. Now, they are worlds. And yet, they still feel like symbols. Europa, in particular, has become a kind of gentle prophecy. Beneath its ice, there may be liquid water. In that water, warmed by tidal forces and hidden from sunlight, there might be conditions where life could survive. Tiny, fragile life. Nothing like the grand beings of legend. No sky chariots, no thunderbolts. Just simple organisms drifting in a dark sea. The thought that such life might exist does more than excite scientists. It soothes something quiet inside the human mind. It says, if life can arise there, in a place so cold and hidden, then life might not be rare. It might be a natural part of the universe, like starlight, or dust, or orbiting moons. Jupiter's moons, glowing softly around their giant planet, become less like threats and more like promises. Not promises that everything will be easy, but that the universe holds more than empty silence. That it has surprises tucked away in its frozen corners. Looking ahead, scientists imagine future missions. Robots melting through Europa's ice. Small submarines swimming in its hidden ocean. Cameras sending back images of strange drifting forms. They picture probes landing on other icy moons, testing plumes, sampling dust, listening for chemistry that hints at living processes. These are predictions, yes, but they are made not to control the future, only to meet it with curiosity instead of fear. And there are other kinds of prophecies written in starlight. By watching how stars move, how galaxies spin, and how light bends around invisible mass, astronomers predict the shape of the universe's future. They trace its expansion, map its hidden dark matter, and measure its age. They ask, will the cosmos expand forever, growing colder and quieter over trillions of years? Will stars burn out one by one, leaving only faint embers and drifting dust? These are not prophecies meant to frighten. The timescales are so vast that they stretch beyond any human worry. Instead, they remind us how precious the present is. This moment, with its living earth, its blue oceans, its storms and forests and cities, is a brief, bright interval in a long cosmic night. If the universe is sending us a message, it may not be in words or symbols, but in quiet laws and repeating patterns. In the way gravity shapes a galaxy. In the way a molecule forms in a cloud of gas. In the way a tiny, fragile cell can grow in a hidden sea. And if, someday, a signal does arrive a clear, undeniable pattern in the noise, it will not erase the stories that came before. It will join them. Another chapter in the long human habit of listening to the sky. For now, the cosmos speaks in whispers. The soft hiss of background radiation, the faint glow of distant clusters, the slow dance of planets and moons. They are gentle reminders that we are part of something wider than our own small worries. As the night deepens, the stars seem to burn a little steadier. The bright points over your head are not there to judge or to warn, but simply to be. In their light, people find their own meanings. Hope, comfort, curiosity, a sense of home in a universe that is still mostly unknown. The old fears soften. The new dreams take their place. And in that drifting quiet, as the sky arches above like a calm, dark ocean, It feels as though some distant truth is still waiting, patient and unhurried. Just beyond the edge of what we can yet understand, the universe feels quieter now. Not because the stars have stopped burning, or because the planets have paused in their endless orbit, but because the story you have been following has slowed to a calm, drifting pace. It settles around you like a soft glow at the edge of sleep. We return, one last time, to the beginning. Earth's first radio broadcast once slipped into the sky. Music, news, laughter, war reports, and love songs rose from antennas and towers and spread into the night. They climbed past clouds and storms, past the thin blue shell of air, and then they were free, racing at the speed of light. Those early signals became ancient travelers. They left Earth behind and traced their own trajectory across the dark, crossing the orbits of the Moon, Mars, and the wide belt of rock and dust we call the asteroid belt. As they went, they carried our fear, our hope, our fragile stories, woven into waves no eye could see. By the time any telescope could focus on them, those waves were already too faint to catch. Still, people imagined them as messengers, spreading like ripples on a black ocean. Some thought, perhaps somewhere someone could be listening. Decades passed. New telescopes were built, patient enough to stare for months at one patch of sky. We found exoplanets, strange comets, and distant nebulae. Yet one place kept pulling our attention back: the giant planet Jupiter, with its swirling storms and hidden icy moons. When the anomaly first appeared, those odd, repeating hints in the data near Jupiter's orbit, it felt like a sudden cosmic whisper in a room that had been quiet for a very long time. Computers checked and rechecked the readings. Teams compared notes. The signals were small, almost nothing, but their rhythm seemed to echo patterns we knew. Not a voice, not a language, but something that felt deliberate. Tonight, as you listen, that moment of discovery sits far behind us, like a memory lit by a fading candle. The anomaly is still unexplained. It might be natural, a trick of Jupiter's fierce magnetic field, or a subtle dance of particles trapped in its radiation belts. It might be the way icy moons bend, reflect, or shape the waves that pass near them. Or it might be something we have not yet imagined, a hidden process without a name. Scientists have come and gone from the project. Some retired. Some moved to other mysteries, to other telescopes pointed at other corners of the sky. A few stayed, steady as the orbit of Jupiter itself, watching the data scroll across their screens night after night. Many anomalies fade into the background, unsolved, part of the cradle of silence around a giant planet. And yet, the listening does not stop. On the ground, radio observatories turn their broad dishes toward the sky. In space, metal arms unfold, sensors cool toward absolute zero, and instruments lean into the darkness, waiting. They trace the paths of our own signals as they move outward, past Jupiter now, past the orbits of the outer planets, into the realm where comets drift like slow, ancient travelers. From far away, if anyone ever listened, Earth would not sound like words or songs. It would sound like a blur, a soft hiss where millions of voices blend together. Inside that hiss is everything we are: the fear of the unknown, the awe of discovery, the simple hope that we are not alone. In quiet labs, people sit beneath dim lights, their screens the brightest stars in the room. They simulate ice-covered oceans on moons like Europa, wondering how cracks in the crust might breathe out plumes that interfere with passing signals. Each idea is like a flashlight beam swung through a dark cave, searching for one shape that finally makes sense. For now, there is no final answer. The cosmic whisper has not grown louder. It has not turned into a clear message. If it is a harbinger of something, that something still hides behind layers of noise and time. But even unanswered, it has changed us. It has reminded us that listening is its own kind of courage. To press your ear against the quiet of space, to hold your breath and wait, is a way of saying, we are here, and we care enough to ask. As you lie there, maybe with your eyes half closed, you can imagine how many ears are turned upward right now, radio dishes. Space telescopes and human ones, all sharing the same sky and the same quiet question. You are one of them. You too are part of this quiet act of listening. The story of Jupiter's moons continues in labs, in code, in the patient work of people who will never meet you, but who share your sense of wonder. They check the anomaly again and again, not because they are sure it hides a message, but because they know the universe is better understood one gentle question at a time. More instruments will launch in the years to come. New probes will fly past the giant planet and skim the edges of its moons, tasting ice and dust, mapping the glow of auroras in its storms. Future telescopes will tune their ears to new frequencies, sharp enough to notice patterns we are blind to now. If there is meaning in the whispers near Jupiter, if some hidden process has been shaping those signals all along, the tools of tomorrow may finally see it. And if they do not, the listening will still have been worth it. In the act of searching, we learn how easily we can mistake noise for meaning, and how bravely we still reach out anyway. We learn to build better questions, to weave new ideas from thin threads of data and doubt. Our signals, meanwhile, keep going. They stream past the scattered rocks of the Kuiper Belt and lonely dwarf planets locked in drifting shadow. They move into regions where the sun is only a bright star among many, where nebulae glow like colored clouds and galaxy clusters gather like islands in a cosmic sea. Somewhere within that vastness, perhaps, another world is doing the same thing, sending out its own quiet broadcasts, turning its own telescopes toward the dark. On a distant moon, orbiting another star, someone may also be lying awake, watching a faint, unexplained flicker in their data and wondering if it means they are not alone. You will not hear the answer tonight. No one will. But as you drift towards sleep, you can picture it. Jupiter hanging in the black, banded and immense, its storms turning slowly like ancient clocks. Around it, its moons move in their patient dance, ice and rock wrapped in a gentle veil of darkness. Somewhere in that scene, the anomaly lives on, folded into the background, part of the place as surely as the magnetosphere and faint rings of dust. The cosmic whisper fades, but it does not vanish. It becomes part of the silence, part of the steady hum of the universe itself. Your breathing slows. Your thoughts loosen, like a comet's tail spreading out behind it. Above you, beyond the roof, beyond the clouds, the signals continue on their way, indifferent and timeless. And in that drifting quiet, as the last echoes of the story settle around you, you might sense that space is not truly empty after all that, hidden in the silence near Jupiter. And in the spaces between every star, there is still something waiting to be understood.